Perhaps we should also close the meeting room and get everyone in.
Should we wait a minute before starting, or should we go?
I guess we can go.
Yeah. Just keeping an eye on the last speaker exchange.
Yeah, I'll be waiting for that.
Okay. Okay, so he cannot access so. Okay, so I propose that we start so that if we want to have time to discuss with all the speakers, we should start on time. So welcome everyone. So it's a great pleasure to welcome you to the Virtual Humans and Crowds in Immersive Environments workshop. So this year, the committee is composed of 4 researchers. So I will give you just a brief overview of the organizer. So Andrea Bonch is a research assistant in virtual reality and immersive visualization group in Aachen, sorry for the pronunciation, University in Germany. And Andrea's research interests include the behavioral design of virtual agents embedded as advanced human interfaces in virtual reality application. Katia Zibrek is a research fellow in INRIA Rennes, and her interdisciplinary research focuses on the perception in graphics, where her primary interest is the use of VR to study the effects of virtual character design. Julien Pétret is a senior researcher in INRIA Rennes, and his research interests are crowd simulation, computer animation, VR, robot navigation, and motion planning. And myself, Anne-Hélène Olivier. So I'm an associate professor in the Sports Science University in Rennes, and I'm interested in visuomotor coordination during locomotion and interaction between pedestrians, both in real and virtual environments. So today is the 7th edition of the workshop, and we would like to thank the IEEE organizers to offer us the opportunity to have this workshop happening today. And as a reminder, the main context and main topic of this workshop is immersive virtual environments populated with characters. And as human interactions are complex by nature and the application of virtual humans and crowds are very wide, we really want to propose some multidisciplinary perspectives So we will try to show that with the panel today. And we also have multidisciplinary speakers during the workshop. So this is a really important point in the workshop. So here is an overview of the workshop. So we will start with some short paper presentation based on a one-page abstract. Then we will have some presentation of European projects. And finally, we will have an exciting panel with the cross-community approaches for virtual agents and crowd with Anton Bogdanovic, Dinesh Manosha, and Nicolas Chavot. So this online experience is really a place to discuss here with speakers. So we will try to save time in the planning to have a fruitful discussion. So please do not hesitate to raise your hand and ask the question or post the question in Discord or in Zoom so that you can really exchange with the speakers. This is really important for us in the session. So before giving room to Katja, I just would like to thank our IPC member who helped in evaluating the short paper abstract. And I think we can start the presentation of the short papers for the first session of the workshop. So maybe Katja, I'll let you continue with the speaker.
Sure. Thank you so much, Anne-Hélène. So I think we're just going to jump right in here. We're going to have 4 presentations in this session. I would probably just start with the first one, which would be Annabelle Limbal, and she's going to present virtual reality boxing, gaze contingent manipulation of stimulus properties using blur. And if we have her in there, please get ready. So basically, as we mentioned before, this is going to be kind of a more relaxed paper session, not like a serious paper sessions that will be presented after. So please make sure to get involved, ask questions. It should be a discussion. And so I'm just going to briefly introduce Annabelle. She is currently completing her PhD in sports sciences at the University of Rennes in France. And apart from sports, her interest lies also in motor control, eye behavior, and perceptual and cognitive skills. To develop these skills and train athletes, she's interested in the use of new technologies such as virtual reality. So Annabelle, if you're ready, you have approximately 15 minutes, 10 minutes presentation, 5 minutes for questions. So whenever you're ready, you can go ahead.
Yeah. Hi, everybody. Thanks a lot. I'm glad this evening to present my work. And so this is about a very special interaction with human and virtual human, the one in sport and especially in boxing. So what is the background about this study? So sport is very specific environment where there is high temporal constraint, but also spatial and even constraint. So athletes have to react very quickly because in boxing, a punch can be there in less than 1 second, and the conclusion can be a knockout and very severe consequences on health and also on performance. So information pickup and processing is very fundamental in this kind of performance, and it's the support of decision-making and anticipation. This is why perceptual motor skills are a key of expertise in every sport characterized by an interaction with an opponent. So there is a need to train these skills, but at the moment, this is not specially focused in training program because maybe we've not got all the tools to do that. And it's also just practice during the global sequence, like the fight or the game, but not directly target. So I was interested in a special method to train and investigate these perceptual skills, which is the use of blur. So it may seem a bit weird, but there is several interests to investigate this method. So the blur removes some of the superficial information present on the vision and the received information. So there were some studies highlighted the fact that using blur on videos can actually improve the performance during visual anticipation tasks. Sorry. So these studies investigate the blur on the wall display over videos. So there is some contradiction between the studies. Whether this is with experts and novices, the result can be different. And also there are limitations because it's on 2D display and sometimes on a three-person viewpoint. So we need more understanding of this mechanism and investigate more deeply the blur, especially the link between central and peripheral vision, because as you may know, the cells from the peripheral vision are basically a blurred information, a low frequency information, sensitive to movement and to colors, rather than the central vision is sensitive to very fine detail and very high frequencies information. So the goal will be to split the central and the peripheral vision and see if we can enhance one from the other. Especially in sport like boxing, there is strategies from the athlete, like the visual pivot strategy or visual anchoring to maximize the eye behavior to reach the best information pickup for performance. So basically, they fixate the gaze around the trunk of the head to reduce the cost of the saccades and get the maximum of the information through the peripheral vision. So for experts, the use of this peripheral vision is very important and need to be enhanced. So for this specific purpose, the group from Rieu and colleagues use this gaze contingency manipulation to investigate differently the central and the peripheral vision. So they apply the blur whether so around the fixation of the gaze, they apply the blur either in central or in peripheral vision. So as you can see on the picture, it was a viewpoint from the backcourt, a 3D perspective. So without adaptive viewpoint, which is very limited. So the results were still interesting. So they exposed that experts were better than novices in all viewing conditions, and they were not a specific facilitator effect of blur, but they saw that experts were more resilient to blur. So in other words, their performance did not decrease that much, whether the blur increased a lot. In another study, after training, they observed an improvement of decision making, and especially that peripheral blur was more effective for novices. So remind it's for novices, this is important for the next. So as I said, there is some limitation about these studies. So mainly it's 2D display, often click button response. So there is no respect to the concept of perception action loop, which is very important in sports. So we can ask whether these skills are really the one occurring in a real sports context. So virtual reality appears like an interesting tool to investigate deeply these perceptive skills with the respect of ecological settings and the perception action loop. So we designed a study to investigate the effect of blur on anticipation performance in boxing, and we were interested how guys could be impacted by this manipulation. So we hypothesize that blur increase the performance up to a medium level blur, but peripheral vision could peripheral blur, could help to improve performance, and also that experts are resilient to the increase of the level of blur. So for that, we go through several steps to animate the virtual boxer, virtual opponent. So we record motion capture on a professional boxer. We use QTM software to do that. And then we develop an environment on Unity. So we use the HTC Vive Eye Pro, which integrates eye tracking, and we use this eye tracking to online follow the gaze and apply the blur in a gaze contingency manipulation. So we've got 18 mixed art and boxing experts for this experiment. It was about 15-minute testing, and we record the number of punch blocks. So it was a defensive situation where the participants have to parry the coming blow of the virtual opponent. And we've got 4 conditions. So control 1 without any blur, the one with a peripheral blur, and the one with a central blur. So about the results on the performance data, we show a main effect of the viewing condition, and especially the performance was better in the central blur and not in the peripheral as we expected. And then we saw interaction between the punch number. So all sequences of punch were 3 successive punch. So punch number are first punch of a sequence and second, third. And punch type was whether it was preceded by a feint, arm feint, feet feint, or no feint. About gaze, so it confirmed the strategy of fixating the gaze around the trunk, because the most time are spent on the 2 fists, the trunk, and the head. So which was interesting to see how participants fixate the opponents. And then we go a bit deeper in investigating the gaze with fixation count and duration. And we see that the fixation count was influenced by the developing sequence, so whether it was the first or the last punch of a sequence, and also the punch type. And about duration of a fixation, we saw a main effect of fixation as well. So altogether, these results present an effect of central blur, contradictory to some of the work on previous work. But this one was with experts. So we know that experts rely more on peripheral vision. So possibly the central blur could help us to rely stronger on the peripheral information. In our situation, peripheral blur impairs a lot anticipation and information pickup. And we also find a facilitative effect of foot feints. The strategy of the gaze, so more and longer fixation, was associated with poorer interception. And the hypothesis about blur could be it's a reinforced use of the dorsal stream and movement processing. So we will continue to investigate the central blur. We need to adjust based on the results some parameter of the task. And there is this confirmation of the overt attention of the upper part of the body. So thanks a lot for listening to me, and I will be happy to answer questions.
Thank you so much, Annabelle. So are there any questions so far? I think you can just unmute yourself and ask the question. No? Okay, I might just ask something very quickly. I was just interested when I was reading the paper. How difficult is it to make an experiment with professional athletes in VR? I mean, I would imagine that the VR headset isn't always stable. If you're delivering these fast punches, probably it can be dangerous for the equipment as well, and the person, of course. I don't know why I worry about equipment first, but that's me. So is there any problems that you were facing when you were working with athletes?
Yeah, so contrary to the picture right here, we decided to, during the experiment, forbid the gloves and just went just with the hand, because with the glove, when they were in the guard, they were just hitting the headset because it's an additional surface, basically. Mm-hmm. So they were just hand bare during the experiment. And sometimes they were very close in regard to the headset, and they have to knock a bit the headset. That was the main issue. About the space, we match the size of a ring with the size of the VR environment, so that wasn't an issue. Yeah, sometimes they knock a bit the headset, but they didn't, after the experiment, share any major discomfort.
Okay, very good. Thank you. I think Bobby has a question there.
Hey, yeah, thanks for the talk. It was nice. So maybe I just misunderstood at the beginning of the talk, but if you could just go over this again. So I'm worried about the field of view of an HMD, and I thought that motion detection in the periphery was just as sensitive as motion detection in the foveal region of your eye. And I just worry that when you restrict in a sports activity like boxing, which is going to be very sensitive to things coming at you from the side and so on, when you restrict the field of view with an HMD for training purposes, you're depriving a boxer of a lot of salient information. So I know that you talked a little bit about this at the beginning, but I think I just missed the point here. So could you just go over that again?
Yeah, sure. So obviously with the headset, we have a small limitation of the field of view. But in our situation, participants were able to see the feet of their opponent, so that wasn't a main issue. It was realistic. And about the vision part question, the cells from the fovea and from the periphery have not exactly the same function, and they are specialized with specialized neural network associated. And basically, the cells from the peripheral vision are specialized in detecting the movement, like sport or daily life movements, rather than the central vision is more for very fine detail. So the first one get an information of low frequency, rather than the last one is a higher frequency information. So we played around these two specificities to try to enhance and in first place understand how this network interact and take part of the information processing.
Okay. Was that okay, Bobby?
Yeah. I guess. And you're saying that velocity information is high frequency information, as opposed to, when I think of high frequency in the visual field, I think of fine detail like texture gradient or something like that. But are you saying that velocity information, so gross movement, like my hand moving across this camera here, are you saying that you consider that to be high frequency information?
No, it's low frequency information. So we are speaking in terms of image detail, and thus there is a dedication specifically to the cells of peripheral vision to detect the movement of high velocity. but this is treated from the eyes like a low frequency information. So basically, you see the movements, but not all the fine details of the object moving.
Right, of course. Okay. Okay. All right. Thank you.
Thank you for the question. We will move on in the interest of time. So I would like to thank again Annabelle for answering the questions. If there are any other questions, you can post them on Discord, and I'm sure Annabelle will be more than happy to answer. So the next speaker is Daniel. Yes, hello. You can start sharing your screen whenever you're ready. So Daniel will be presenting a short breaking research titled An Embodied Conversational Agent Supporting Scene Exploration by Switching Between Guiding and Accompanying. A little bit about Daniel. So he's a computer science master student at RWTH Aachen University in Germany. During his study program, Daniel was working as a research assistant in the field of social VR, focusing mainly on group formations and intergroup communication at the virtual reality and immersive visualization group. So here, Daniel is currently writing his master thesis about creating an embodied conversational agent supporting scene explorations and cities. So Daniel, whenever you're ready, you can go ahead.
Yeah, thanks for the kind introduction. Yeah, so my name is Daniel, and I will basically present my master thesis, which is still kind of in its early stage. So I will present this topic on behalf of Andrea Bönsch, Jonathan Ehret, and Thorsten Kuhlen. And yeah, my thesis is about creating an embodied conversational agent that supports scene exploration by switching between guiding and accompanying in hopefully a clever way. So our motivation is that whenever a user enters a virtual world, the first response is always that he looks around. He tries to familiarize himself with his surroundings, and then he would walk around and tries to explore the environment. But this task is not so straightforward anymore, as like virtual worlds becomes quite large these days. So the cognitive load on the user is quite high. So we, as the designers of such applications, should assist the user in this task. And we could do that by providing a virtual map or by rendering arrows or lines to visualize a path, something like that. But these measures would be quite intrusive and break immersion and are not really a good option for virtual reality. So a common way to assist users in the task of scene exploration is to incorporate embodied conversational agents. So how would we model such an agent in virtual reality? So if you think about in reality, you want to get to know a new city you've never been to. A nice way is actually to participate in a guided tour in that city. And this is actually a common way how we would model such an agent in VR as well. So we would model him as a tour guide. So then the whole experience is quite structured because you go from one location to the other, and the guide will make sure that no information is missed. And you can now fully concentrate on gaining knowledge. A huge drawback with this approach is though that now you as the user become a passive listener, and the whole experience is not really that interactive. And as virtual reality is quite an interactive medium, I think we really should address this problem. So another approach would be to use a companion. So in this case, the user would explore the scene by himself and has the agent as a companion that he can ask for questions. But now the whole experience is unstructured, and the user might also miss critical information. And now the cognitive load is again on the user as he needs to orient himself. But the huge plus with this approach is now the user can control the pace and the structure of the tour himself. So Andrea Bönsch, amongst others, actually asked the question already if being guided or having exploratory freedom is more beneficial for scene exploration, and there was no clear preference. So how should we model this, using a guide or a companion? And this is where I want to combine the two approaches, and I would like to create an adaptive guide that is more interactive, that adapts his behavior to the user's preference, but still provides a structured experience. Our scenario is that we have a large outdoor city environment, and a tour would then look similar to this. So we start at some point, and then we will be guided among different points of interest, like, for example, a church or a building that has a particular fancy architectural design. But we also model areas of interest that would, for example, be a park that contains multiple points of interest, like a fountain or a statue. And whenever we are at an area of interest, our guide will switch to the accompanying behavior. Otherwise, he will be in the guiding behavior. And yeah, because the user can then freely explore these smaller areas of interest. So the cognitive load here is not quite is not that high, because these smaller areas, they are quite easily observable. And our guide will also make sure that the user at least notices all the points of interest inside these larger areas of interest. So yeah, he can freely explore these smaller areas of interest, but we still make sure that he at least notices all the points inside of them. So this is like a first step, how we try to make our guide more interactive. But for the most part of the tour, we are still in the guiding state. So we also introduce additional measures to make this guiding state more interactive. So the user can passively and actively influence the guide as well. Passively, because our guide will actually analyze the user's proxemics and his gazing behavior, and then assess if the user is interested in something or not. And the user can also actively influence the guide by speaking to him or using gestures. Now I would like to show you a short video about how a guide approaches a point of interest. And the first thing the guide will always do is give a general introduction about the point of interest, during which the agent can then assess if the user is interested, or the user can also assess himself if he is interested in what the guide is telling. And yeah, then the guide will either give more detailed explanation or move on with the tour. And in this video now, the user will pay not too much attention. He will like frequently gaze towards the fountain, the background. So our guide will come to the conclusion the user does not want to get more information.
The statue shows the founder of our city, Mr. Madeleine. Well, he technically did not found the city, but he brought it from a bankrupt small town to a thriving and quite prosperous city in the late 1830s. Later it turned out, though, that he was actually living under a fake name to hide the fact that he was imprisoned for 19 years. Apparently he stole a loaf of bread to feed his family. It's quite a drastic sentence, if you ask me. Alright, I see you're not that interested, so shall we move on? Okay, let's proceed.
Yeah, so the guide quickly gave confirmation that he noticed that the user is not interested, and then he would wait for the user to confirm that indeed he wants to carry on with the tour. Yeah, and in the end, we also plan to have a user study about this. So this is not final yet how we will design it, but it will probably be a between subject design where the first group experiences the tour with our adaptive guide, and the second group who would explore the city by themselves to like have a comparison here with our agent. And then we want to know, does our adaptive guide, or how does our adaptive guide influence the user's comfort, perceived presence, and spatial awareness? And ideally, we would also like to have a third group that takes the tour with that takes the user with where the user takes on the tour with a traditional guide, and a fourth group that just uses a companion, so we can really compare how does our adaptive guide improve over these aspects. Yeah, so the city we are planning to have this study in is a fictitious city, so the user does not already know it, but we still try to model it after a real city. So we have like larger streets, also like bigger squares, but also very narrow streets to have a good mixture of everything. Yeah, that brings me already to the end. So thank you for your attention. I have written down some questions that you can ask, but we can also discuss anything you want. So I would like to know if you agree with this switching behavior based on points and areas of interest, and can you think of other techniques how we could influence the guide as well to make it more adaptive? And do you think that our user study will give us the intended insights? Yeah, thank you for your attention.
Thank you so much. Very intriguing work. Is there any, maybe first, is there any comment to the questions and the feedback Daniel is asking? Does anybody have any suggestions? They can just unmute themselves and. Everybody's shy today.
I mean, you can think about them and then ask me or write me in Discord if you think of something.
Absolutely. Maybe it would be good to have those specific questions written down on Discord, just so people know what to target. So this environment was made in Unreal, right? It's
yeah, we will use Unreal Engine 4, and yeah, our guide is a metahuman, and yeah.
So you're going to make the facial animation as well. You're going to use the full rig.
Yeah, I currently use Oculus OpenFace, where you can transfer WAV files to these facial animations. Yeah, that's the plan.
And do you think that it also strongly, like this sort of setup, it strongly probably depends on the type of task, I mean, or the type of environment as well. So the environment you showed, are you going to think also about how to construct it in the right way so people will know, people have an easier way to navigate through it? Or are you still developing the environment, or are you kind of set?
Yeah, so it's still in development. I haven't really thought about what are the exact points and areas of interest. So ideally, it should be a little bit harder for the user to explore the city by themselves. So maybe we want to hide them a little bit. Yeah, but especially in these areas of interest, everything should be easily observable, and it also should be quite clear what are the points of interest.
Excellent. I see Anne-Hélène has a question.
Yeah, thanks a lot for your talk. So, or maybe I missed something, but I was wondering if you consider to manage some eye contact, or at some point to maybe to manage the timing of the interaction. So maybe give time to the user to at some point discover the area of interest, and then engaging the conversation based on some non-verbal communication when the user is ready to engage a discussion with the guide.
Yeah, I try to do it as naturally as possible. So like the guide will, I try to model that he has a natural gazing behavior. So he looks to the user and to the point of interest, like he switches his gazing behavior there a little bit. And yeah, at these areas of interest, yeah, the user will probably walk around the area freely by himself. And then I haven't think about it too much, but maybe he will just call the guide, or yeah, maybe gazing to the guide will already be enough. So the guide will approach him, and then he can ask him about anything that he's interested.
Okay, thank you.
Okay, so I suggest we move forward for now if there's no more questions. I see that the questions were also posted to Discord, so please, if you have any comments, do answer and do give some feedback to the presenter. And so we will be moving to the next presenter, if that's okay. So we're still not quite sure about the last one, just to give a short kind of information about this, because the last presenter wasn't able to sign in. So we might have some extra time on our hands to discuss things further, but we'll let you know after this next presenter. So the next presenter is Jonathan. And yeah, so he's here, good. So he will be presenting a short research, or a short late-breaking report titled Natural Turn-Taking with Embodied Conversational Agents. And just a short introduction to Jonathan's work. He's another colleague from Germany. Jonathan holds a master's degree in computer science from RWTH Aachen University and is currently a PhD student in the virtual reality and immersive visualization group at the same university, led by Professor Torsten W. Kuhlen. His research interests include the behavioral design of embodied conversational agents as advanced virtual interlocutors in virtual reality applications. And besides research on co-verbal gazing and gestures, he also focuses particularly on acoustical phenomena during the ACA speech. So, Jonathan, I hope that was okay. And the virtual floor is yours.
Yeah, thanks a lot for that kind of introduction. And hello again and welcome from my side on this presentation, or rather, I would say on this invited discussion about natural turn-taking with embodied conversational agents. I'll be presenting also on behalf of Andrea and Torsten. So let me first start by telling you in which project context this whole study design I'm presenting here will be taking place. So we're doing an interdisciplinary project together with some psychologists and acousticians, and we plan to conduct experiments on listening effort in a closer to real environment than what is currently often done. So for example, often nowadays serial recall tasks are used where acoustic sequences of number need to be remembered and reproduced by participants under different potentially adverse hearing conditions. And then they have to reproduce these numbers. And we want to use more realistic task developed by Finter and colleagues, namely the heard text recall task, where different family stories are told by two talkers. So in our case here, these two agents. So let's have a look at one of these stories. So for example, the female agent would start by saying, okay, Rosa lives alone in a small 2-room apartment in Hamburg since retirement as postal worker. And then the male agent takes over and says, okay, her twin brother Vincent is also still alive. He's 80 years old and fortunately lives only 2 streets away. And then they go on and they swap who's speaking in between. And these stories always consist of 10 sentences, and we have around 30 of these stories at hand. And then after each of these stories being told, participants are asked to answer some content related questions. So for example, here, how old is Vincent? And the idea is that they need to remember what has been said and also combine different pieces of information, potentially even given by different speakers. So here, for example, how old is Vincent can only be answered if you remember the second and third sentence together. Okay, so we want to examine listening effort by responses to these content questions and also by means of a secondary task performed in parallel in a dual task paradigm. And this secondary task can be, for example, reacting on vibration of your controllers and then clicking buttons, and we measure how long you take for performing this secondary task. And then we want to examine the listening effort when changing different factors, for example, acoustical factors like correct sound source placement, individualized head-related transfer functions, or generic ones, background sound, and so on. And we as computer science partners or VR researchers want to see how the degree of immersion influences listening efforts. So for example, whether you see it in a cave room-mounted display, a head-mounted display, just on screens, or maybe without seeing anything. And then we also want to look into, and that's what this talk is more focusing on, the non-verbal behavior of the agent. So for example, whether they show fitting or non-fitting co-verbal gestures with regard to what they're telling you, and whether they show appropriate turn-taking signals, or whether they make them at weird places, for example, when there's no handover of turn. And then we want to evaluate listening effort as a proxy potentially for social presence. Our hypothesis here is that wrong agent behavior lowers the social presence, but also increases cognitive load because you have some dissonance of what you expect the agent to do and what you actually see. And thereby also the listening effort should be increased. And then we hope at the end of this project to see that there's maybe a negative correlation of those. What we need for that is we need, first of all, good candidates for the co-verbal behavior, so fitting and non-fitting co-verbal gestures, and also an understandable implementation of the turn-taking signals given by the agents. Okay, So the study design I want to show you here and discuss with you, it has two parts. The first is the listen part, where the two agents present her text recall stories, and then participants rate the naturalness and social presence of these agents. And then we want to see whether we can find good candidates for fitting and non-fitting co-verbal gestures by means of recording some gestures with this sketched mocap setup here, and record multiple motions per sentence, and then see which is rated best, and also see what are good candidates for non-fitting gestures. So maybe use movements of another sentence, maybe use no movement or random movement. That's not yet fully decided. And then the second part of the study will be that the participant takes over one part in presenting the family stories. So to not change the conversational setup, we add an additional listening agent that takes over the participant's role from before. And we have these two information. So that's the information that the participant sees. So the sentences that should be read out, and that's the information he knows, the agent knows. And both know exactly who's going to start the discussion, and they know when to hand the turn over. So here, for example, the agent knows that the user starts, then at some point here, the agent should take over, and at this point, the agent should give back the turn to the user or participant. And here, the participant knows that he only has to say one question, one sentence, and then pass the turn over. So both have to react to the turn signaling for taking the turn. And for the agent, we want to realize that by means of a Wizard of Oz paradigm, where the wizard controls the agent to react to the turn-taking cues. And then we want to measure co-verbal gestures and turn signaling of the participants to potentially even improve our co-verbal gestures. We want to measure social presence, but most importantly, we want to measure the gaps between turns. And we expect the gap to be larger when the agent is not signaling turn correctly, or not at all, because obviously participants then don't really know when to take over the turn and just wait longer. And also it is interesting to see whether the participants maybe adapt the way they signal turn taking to the way the agent signals turn taking. So let me quickly explain how we plan to do this. Linguistic features like sentence structures and so on, and prosody, how you pronounce and the frequency of your voice are important for signaling turn taking, but are not possible here because we pre-record all the sentences. So we will use gazing, where you normally gaze at the other when yielding the turn, and otherwise avert the gaze in the gaps between turns. So if I look away, then I probably want to keep the turn. And gesturing, so normally you hold co-verbal gestures during the gap when holding the turn, and you end the gesture before the gap when yielding the turn. And at last, we want to also see whether breathing can be used, because if you audibly breathe in during the gap, then you most often want to hold the turn. Okay, so this already brings me to the end, and I also brought a lot of questions, and would be happy if you share any ideas, maybe on these questions, maybe on other stuff, maybe now or on Discord. So one question would be, how can actors, so for the mocap, be briefed to gesture naturally when performing? And then we also discussed how to measure social presence. We so far used the social presence survey, often by Bailson and colleagues, but also heard that Lombard's temple presence inventory could be maybe a better choice to go for, because the SPS is particularly hard to answer by participants. And then most important question, do you think that this approach is promising to study turn taking for embodied conversational agents? Because maybe reading out the text from a board can be problematic, and maybe you have ideas how to circumvent that. And last question, do you have any ideas on the best non-fitting gestures, so with the worst social presence? Because we actually need to have high differences in social presence to be able to correlate that with listening effort in the end. Okay, thank you for your attention.
Thank you very much, Jonathan. So do we have any questions or suggestions to Jonathan's questions, maybe?
Not fair. You can also have other questions, obviously.
Yeah, no, of course. Maybe I can just for the board, maybe. Okay, I see someone is, I can ask later. Go ahead, Ishan.
Hi, good morning. Sorry, maybe good night in German. I'm in New Zealand. This is super interesting. Because I'm working on in Mark's Billinghurst lab. So basically, what he wants me to do for the project is, I think your stuff, it's kind of related what I'm currently doing in the lab. So one of the things that we plan to run an experiment, supposed to be this week, but then I got COVID suddenly, and that it's really hard. It got a whole thing in my family, so I have to postpone it. But since I read your stuff and I forced myself to wake up to talk about this, because this is super interesting. So what happened is we want to pick up several agents like this, but then we also want to measure the social presence. And also in the previous experiment, we tried to measure if these two agents, like a simple agents that have how much when the gaze meets each other. So what we are trying to investigate, when there are two different agents, of course there are two people, and how much these two agents will impact the interband synchrony between these two different agents. So for example, Jonathan, if you're using a certain one avatar and I'm using another one here, and then we have like a kind of simple conversations, and then what we're trying to do, how much our brain will be synchronized with one another, even though we don't see each other geographically. So this is something that we're trying to explore as well in the lab. So how to measure the social presence, maybe something that we try to measure a little bit more, how we feel interpersonal social presence between two people.
You mean like feeling connection, like rapport or alignment or these kind of?
Yes, exactly. Because in something that we miss is we didn't measure this, we didn't have this social subjective measurement. So we only measure the interbrain synchrony. What we found is basically the natural gaze like this, because we measure different type of gaze, like direct, averted, and natural. So what we found out, as people have natural gaze, so basically it impact more the interbrain synchrony between people. But then in the next one, we want to take the measurement by using the subjective experiment. So we want to see whether the interbrain synchrony will also have a correlation with the subjective measurement and interconnection social presence. So yeah, this is something I think hopefully maybe
so
we
I would be glad to take this offline and also like discuss your studies in depth, obviously. So you're taking brain data like EEG or something like?
Okay, that's right. And yeah, because this is related, because talking also about gesture, because in our experiment we only use simple gesture like finger pointing and finger tracking as indicating there is like follower and leader, something like this. So yeah, I think so there's something we want to explore, whether to what extent the what do you call like virtual agent impact the interbrain synchrony basically.
Okay, yeah, so thanks for sharing that. Is there any particular question you have right now? Otherwise I would be glad to discuss in depth with you.
Yeah,
maybe not in our night time, but
yeah. That's all right. I just have basically one questions, whether you have any for example any specific design for example in this, whether you have any specific concept when you design a particular agents, say this one, for example, more naturalistic avatar and the other one is like less realistic avatar, whether you considering this aspect and that whether it would impact later on how these two people will behave probably.
Okay, so we normally strive to go for the most realistic avatar agents we can get. I mean, always is the uncanny valley problem. But yeah, and design and directions, right? You cannot really measure social presence if there is no real interaction. Then this is like even harder concept for participants to answer. I still in my studies, I found that people find it particularly hard to answer this SPS questions because they're like very like, yeah, hard constructs to like think about for agents, especially if you really are aware that this is just an agent. Yeah. But yeah, let's take this offline. Just drop me your email on Discord, and I'll get in touch. Or yeah.
Sure. Thanks.
Cool. Thank you.
Thank you. I'm very sorry, we'll have to move on with the next speaker. Bobby, if you have maybe a fast question, or you can leave it on Discord, whichever you prefer. Okay, I think you're okay. Okay, you were muted. Okay, so I'm very happy that we got our last presenter. We weren't sure if he will come, but oh, thanks, Jonathan. Sorry, I completely just went forward. But Vino has joined us. Vino, can you hear us okay? Can you maybe say a word or two?
Yeah, I can hear you.
Brilliant. Okay, so you managed to get in. That's very good. Okay, so can you maybe just try sharing your screen, your presentation? Sure. So Vino is going to present the last final paper, which is titled Mixed Reality Pedestrian Simulation for Behavioral Studies. And Vino is a PhD student working with the control of behavior in shared spaces using AR. Having completed his master's from India, he's a DAAD research scholar in his third year of PhD. And in his topic, he deals on how AR can be used to influence the behavior of traffic participants like pedestrians while walking in outdoor shared environments. And he also included some hobbies here. So his hobbies are working out, cooking, and movies. So thank you for that. And the virtual floor is yours.
Yeah. Hi, and thank you, everybody. And first of all, thank you for this opportunity. So I would like to take you through the small work which we have done and would like to get some initial thoughts on the directions which we are heading for. And my topic basically deals in terms of using mixed reality, and we would like to use it for simulations and to be specific for pedestrian simulations. This work has been done as a part of the Leibniz University, Hanover. The main motivation for our work has been the concepts of safety and specifically the safety of the zombies. Zombies, as you can see, are basically pedestrians who would walk in outdoor spaces while they do not pay attention to the environment, and more specifically in outdoor spaces where there would be interactions with other people like cars and other cyclists, for example. There has been studies, for example, in Cologne that pedestrians usually put their heads down and they focus on the smartphones while they're walking in streets. This has been a safety issue that specifically in Hong Kong and China, they have introduced a specific sidewalks where such users could actually walk in. And there has been focus in the traffic community to introduce some specific lanes for their safety. The American studies have found that nearly 28% of many of the respondents usually do other activities like reading and texting while they're actually walking in such spaces. And our motivation has been to specifically study such kind of behaviors in environments where it would be more shared, or more specifically where there are no regulations. So people are more or less distracted and they're not paying so much attention to the surrounding environments, and environments like a shared space where there would be cars and cyclists and other road users. And there has been specifically studies where they have mentioned that people, or for example, who use an AR game, for example, the Pokemon Go, have nearly 22% of the people are more or less paying attention, and this has been not paying attention. And this has been a problem in terms of security and collision with other people. And to this effect, we were more or less looking at an environment where we could simulate such kind of behaviors. And to this, we made a very first step in terms of realizing a possible interaction or simulation environment using mixed reality, where we would like to present to you today. In this specific work, which we call as the Mars BCARS system, we basically have a mixed reality environment where we try to realize an outdoor shared environment space, like a shared space. And our specific motivation for this work has been in terms of interconnecting different components of both the real and the virtual world, where we try to say that where we have a real agent or the person who would wear such AR glasses, and they would occupy the environment with a virtual agent, for example, that of a Unity agent. And then we have an external person who could actually see such interactions using a multi-agent viewer, or a third-party person who could see some kind of interactions or simulations like these. And to realize our framework, we have different components where we would say that the person who would do the experiment, whom we call as the HoloLens agent, would connect to our framework. And we have a multi-agent system. And this multi-agent system would be used for basically interactions or simulations. And they would be connecting to the whole framework using WebSockets. And we also have a viewer component where we can actually see such kind of interactions using a third-party perspective, and at the same time record the interactions happening in the real world, which is mixed with the agents of virtualization. And to have a small framework, or to have a small visualization of our work, we have a small demo of the actual working of the environment, wherein in the first step, we do calibration, where we try to calibrate the virtual world with that of the real world. And in this step, we try to align the virtual world so that the virtual world is exactly aligned to the real world, or the virtual world and the real world are in alignment in terms of its coordinates. And once both the real and the virtual world is aligned, we go with the next step, where we try to have the actual experiment performed. And we have multiple iterations in this. So we have both the real and the virtual aligned. In this figure, we can see that the person who is actually doing the experiment, and on the figure on the right shows a small viewer of the whole framework, where we can see that the real person who is shown in terms of red, and as he basically walks in the real environment, you can see his trajectory or his motion is recorded using our framework as he moves in the indoor space, for example, a room. So as and when he moves, using the position information from the mixed reality, we are able to get his trajectory motion. In this specific scenario, we show when a 3D avatar is introduced into the mixed reality environment, we are able to observe that the position of the real agent is also recorded. And at the same time, the 3D agent who is moving in the field is also recorded using our framework. And in the third scenario, we have recorded a case where rather than just not interacting with each other, we have an interaction scenario where both the real and the 3D agent, they confront each other. And once it's obstructing their path, the virtual agent actually moves away. And you can see from the figure that he actually moves from the path. And this movement is recorded from the trajectory. And hence both the real and the virtual agent are trying to interact with each other using our mixed reality framework. So the other important contribution is that we have developed this specific viewer where we try to record whatever interaction happens between the real and the virtual agent. And this viewer could basically be used for understanding the behavior would happen during the experiment, and at the same time analyzing what went wrong, and at the same also understanding what the data which could be done in a post-processing manner. So it basically has options to start the simulation. At the same time, we also have option to stop it. And also each recordings for the experiment can be accessed in terms of having the trajectories observed during the experiment to also understand what went wrong, and also to improve the whole experiment apparatus. So having this initial prototype of mixing both the real and the virtual agent, our focus has been in terms of realizing a mixed reality environment for basically pedestrians and other agents. And we have made some contributions in this direction first. And now our current work has been to also include other real people who would be in the scene. And for this, we are currently using the RGBD sensor from the HoloLens. So we are not just using the position information, which would be available from the real world, but we are now trying to come up with a 3D object detection approach, where we would, whenever an experiment happens, we would like to detect the people who would occupy the experiment. And this would also be included into the framework which we are currently developing. But we are also facing limitations that the framework is currently small and it is confined to smaller spaces in terms of realizing it. And our future work has been more in terms of realizing our motivation, where we could possibly not just include pedestrians, but also other agents like maybe an autonomous vehicle or other road users. But since this has been our initial work in terms of mixed reality, we have some open questions which we would like to address with this workshop, which basically deals with virtualization. And our initial questions had been whether will actually a participant who is part of a mixed reality simulation behave the same way to that of experiment to that of a VR one? And if there were any interesting safety critical scenarios where both the real and the virtual agents would also be existing, and if this could also be some of the interesting areas where we could focus on. And since our efforts have been more in terms of adding both real and virtual agent into the same scene, we were interested to understand if adding real elements to an experiment could be a way of possibly, say, improving the limitations observed in virtual reality experiments, and if there were some interesting areas we could also look into. And we were also interested to understand if there were some specific factors which we should be considering if we were to design mixed realities for pedestrian simulation or pedestrian simulation studies. So these were some of the open questions we had for the workshop. And we would also like to understand how you felt about the whole framework and some initial feedbacks of the complete system. So I thank you for the opportunity and apologize for the difficulties in possibly bringing up and joining the workshop.
That's great. Thank you, Vinu. We love to have you, so it's not a problem at all. We only have a couple of minutes until the next session. So if we have any quick questions, we can take it now. Otherwise, I suggest that Vinu posts his questions on Discord and you can take the discussion there. So are there any questions, comments to the presentation so far?
Thanks a lot for the presentation. It's really interesting. I'm curious about, do you have first insight about the behavior of your person interacting with the pedestrian in mixed reality? Because this is some question we get, so we start knowing kind of better how you behave in VR. So what do you observe when interacting with this pedestrian in mixed reality?
So our initial understanding was that the since the pedestrians were in a mixed reality environment, we always observe some kind of a delay between the real and the virtual. So even when the real motions were maybe happening at a faster rate, the virtual was not actually meeting up to the expectations. So the first problem which we foresaw in our framework was that there was a significant delay between the synchronization between the real and the virtual. And this was also replicated in terms of interactions. So this was our early observation, but we have been trying to make some steps in terms of improving it by possibly reducing the latency in terms of the communication between the agents in the whole framework.
Okay, thanks.
Thank you.
Any other suggestions? Questions? Okay. I think we can take the rest of the discussion on Discord. Thank you again, Vino, for joining us. And I think now I'll just leave the floor to maybe Anne-Hélène or Julia.
We take it. Thank you, Katja. Yeah, sorry. So we were meant to have a short break before the next section. I think we will simply skip it in the sake of yeah, keeping track of the clock and yeah. So next session is on EU projects. So as you know, European projects can be kind of large, and they are seeking for opportunities to communicate on their results or to outreach, perform outreach activities. So we invited 3 relevant projects to present the results to the workshop. So there will be the project Present to start, which is about photoreal sentient entities. So basically how to come with the next generation of virtual humans for VR. Second project is CLIPE, dedicated to the creation of lively and interactive virtual environment, which are populated with virtual humans, so very relevant to the workshop again. And the last one is Motif, Moments in Time in Immersive Virtual Environments. So there will be a presentation of some peaks of those projects, starting with Present, as I said. And for Present, we will have two persons from Crew presenting the project and especially the activity in the project. So I'm very happy that Crew accepted to present here, because they're a bit different from what we are used to, and especially I think there is this one sentence in the full bio of those people that you can read on our website. And Crew is summarized like this: Crew is an artistic vehicle for experiments and is composed of scientists and artists. So I think it summarizes the thing quite well. And I will let Eric start to present his slides. So if you want to start sharing your slides, Eric. And after Eric, we will have Ishtar presenting also. Ishtar is a media artist, electronic music composer and performer. And he developed also skills in this 3D modeling, audio synthesis, and game engine. So you will see 2 aspects of their work. Thank you, Eric. You can go ahead.
Okay. Can you hear me now?
Yeah.
Okay, you have my screen in front?
Yeah.
Okay, thank you. Yes, so we started in the 90s somewhere, and indeed it's a collective of artists and scientists, and we work together in the labs right from the beginning. The idea is that we develop things as we want to develop things, really to develop a medium and to know how it works and to discover and explore the nature of the medium. That sounds a bit theoretical, but I can show you with this image here. This is a movie part of a performance we made in 2002. It is a paralyzed man, so he was paralyzed up to his shoulders, and he made him steer and direct the whole performance using the movements of his head, his tongue, and things like that. The idea was that we made media, or we were considering media like a prosthesis. That was like a slogan for us, but in fact it came out that it did work like that. So we had to develop tools for him to make it easy. In the beginning he became really sick because of let's say simulated sickness type of things. and then when we found out how to do it, he said things like, I really feel I have a body again, and things like that. So the step for us was then to go and develop an idea, like if it works for him, instead of looking upon him like you do in a theater piece, the theater goer should be where he is, and the theater goer should be possible or enabled to experience a medium like a prosthesis. So that was the start of what I'll show now is working with VR. In those days, VR was computer graphic based, of course, and why does it stop? And that was problematic. It was expensive. You couldn't take it on a stage. So we developed together with the university and with engineers, we developed our own system, which was video based. It was based upon 360 degrees cameras, which we had to build ourselves. The software had to be developed and everything, but actually it worked perfectly well for doing performances. And so right from the start, we were having people moving around, switching from live to pre-recorded. And here, for instance, you see you have the people are wearing the cameras themselves, so you can walk out from the body of the other person. So these were all very interesting things to work with. One of the things we quickly found out was that to make it workable, you needed to move. What you see here is that we're also using the outside of the performance in order to enable much more people to have more people inside and to turn it into a kind of a spectacular show as a whole. Wait, I'll show you some other examples. Yes. So what I just wanted to say, the idea of moving inside of this world quickly became very important to us. And what you see here is an installation we made in 2015, I think, whereby you see a person walking in a cave. The person is not wearing stereoscopic glasses, only we are tracking the position of the eyes, and the person is covering one eye, and you had perfect 3D. So you had perfect 3D using one eye only. So that was a clear proof that we see space and we feel space because we move, not because we have two eyes and there's in the stereoscopy of it. So it's because we are moving. So that took us further in the research. Ishtar will in a moment explain. We left the path with the video-based VR. We moved into computer graphics again. In the meanwhile, you see some staged shows that we are making using motion capture and all this kind of technology. That was also interesting for us to bring that in the kind of things we do with the immersions, as we call the people being immersed now. And the last thing I'm showing you here is the latest application on which we're working right now. And that is a medical application, so to say. It is a way to treat people for depression. We are developing that with some neurologists and psychiatrists, and we're working on that right now. So we are measuring, we are having feedback. They are measuring taking a picture of the brain before and after. We don't know yet whether it's really working, but so that is a part of the research which we are in now. So that gives you an idea of the scope of the things we do. So we are in arts. We like to work together with scientists just to find out the way we should go. So there is no market objective of anything like that. It's purely what is the way to go? Where are the possibilities? Where are the potential of these type of tools? I think I can switch now to Ishtar to explain what we are working on now. Ishtar joined us 2 years ago, so he's very good. So he's in the digital part, and he's a technical. He calls himself a technical artist. He's an artist foremost. Ishtar, I suggest you continue.
Okay, maybe you can stop sharing, then I can. I can already start talking. So yeah, I was recruited in Crew for developing the present project, which was actually new for me. I did not have a lot of experience working with scientists and industrial partners in this sense, but I did have some experience in 3D and in game engines and things like that. So inspired by the present project and especially the work of INRIA, we started making mock-ups. And thinking of which situations would be interesting as use cases to start developing. And so present is about photorealism, but I much like to stress the realism and not the photo, because we believe very strongly that uncanny valley is a very strong problem, and that it's actually not necessary to emulate humans in such a way, and it's much better to keep stylized forms of humans that are more relatable if you have very good interactions, if you have very good and so realistic animations and those things. So what I did was I made the scene in Unreal Engine where we have an avatar that interacts with a crowd. The crowd becomes aware of the avatar, and if the avatar comes closer, they start surrounding him and they start making gestures. Now, you can immediately see the problem. Well, first of all, it's a completely scripted environment, so it's completely static. It works with trigger boxes and like very basic AI, games AI, and you can't really go very far from this. It's always the same. It's always fixed. It's not very flexible, and it's very difficult to make convincing interactions like this. And so I pushed it a bit further, which is kind of the state of the art in games AI, which is an environmental query system. And so this is a more intelligent avatar. He will hide, and every time when I come closer, he will go to another area. But it's quite easy for me to break it. Like, for example, I can push him in a loop, like I did here. So this is a more advanced and more interactive system, but it's still easily broken. So we went to India. We had a lot of discussions, which were very interesting and very promising. And so Adele, who was working on this interaction fields, which is a GUI tool for humans, crowd simulator, then took our example and actually made it into something which is much more interesting, with some kind of types of force fields in a way, which interact, and where she actually made with the team a hide and seek application, but which is much more advanced because it can go, it can work with moving objects. It can do all kinds of things, and in a very quick way to scenarize the situations. So for our installation that we're making. So this is the idea. We take this research and we try to see what is inspiring in it, what is interesting in it, and then we try to make something around it and see if we can just put it in the field. It can be rough, it can be prototypes, but we try to make something. Out of it. And so for us, the essence of the present project is, of course, digital humans, but what is life? What is AI? What is just an embodied presence? What is recorded? What is the relationship of ourselves to these kind of entities in VR? So we made an installation performance around it, based on scans of railway stations where people would sit perfectly still. And so we have these kind of weird statues. And from these statues, we started building abstract avatars, which we take away parts. We make abstractions of these avatars. And we started making scenarios in interaction fields and humans simulator to be able to integrate them in our interactive experiences. So it's different than working in pure science, in a sense, is that we're not looking for the truth or something like this. We're just looking for an experience, and we try to find something interesting. And so, for example, we had the immersants sit here. They would be sitting there and interacting with an embodied human and a canned mocap. animation. And it would actually be a very meditative experience for people to just be there and not realize what is real, what is not real, and questioning the nature of what they're in. And so, for example, we integrate actors. So the actor is in a mocap suit, and the actor acts.
Can we see that?
Yeah, if I can interrupt you, we still see Unity, and we don't. I don't think.
Okay, no, that's not the idea. Okay, wait. Yeah, and probably yes. So I'm going to quickly recap. So these are the statues that I was talking about with the 3D scans. Do you see it now? Yeah. So these are the statues I was talking about, and this is then the actor in a mocap suit who is interacting with the person in immersion, and he acts as a guide, but also as a performer. He controls how you go from scene to scene, and he can also start playing with his presence. He knows, for example, that this that the avatar sitting is a mocap thing, but then he starts imitating it, and all these kind of plays, which really question, like, why are we in this installation? What does it mean to interact with a digital human in a more abstract way, which leaves a lot of room for interpretation, and it's less clear in a way for the person in immersion, and so in a way more interesting.
Actually, Ishtar, it's difficult to understand the images. So the movie is not running as a movie, so we only see separate images. So it's difficult to understand.
Sorry again. I cannot optimize it for video clips, so that's kind of the way it is. I cannot help it. Yeah, it's a pity. I do not have this option of optimizing.
Now we have movement. Now we have movement.
Okay, weird.
I do.
Yeah. So here you see, for example, the actor strikes a pose, and so he pretends to be static, and then he can start moving again. He will touch the immersant, for example, and start playing in this way with his presence in this world. So we're at an intermediate stage with this performance. We want to start integrating really much more the crowd simulations. But for this, we've run into a very difficult problem, which is animation. So so subtle locomotion, realistic locomotion, happens to be very hard, and it's one of the things that we are hoping we can solve in the very near future, because this is really essential, we think, for populating virtual worlds in an interesting way. It's all about the animations. These are canned animations, and they look amazing, but to make them interactive is a very strong challenge. So that will hopefully be for the next iteration of the project, which we hope to present at SIGGRAPH.
But anyway, we could already have a view of what it would be, since the actor was mixing his live performance with the performance which was recorded, and the person inside, the immersant, it would be very difficult for a person inside to know who is real, who is not real. So that was already giving an idea of how can you have all these avatars react to you.
Yeah. Okay, that's it for us. I don't know if you have any questions.
Thank you very much, Eric. Thank you very much, Ishtar, for your presentation. I think it's refreshing to this community, which is not used to this kind of application of our work. While people are thinking about their questions, maybe I can add that for us, it's really amazing and interesting to say let you play with our tools like just toys, right? And that's really amazing what is out of that. I'm always super happy to see such videos. Any question to Eric or Ishtar?
So it was clear.
It was clear. Well, I think, let me say, I think, yeah, maybe there is an effect of surprise there. So maybe this will leave people with no voice.
Yeah, so as artists, we are not always very clear.
Okay, thank you so much. So if there is no question, I think we will move on to the next project, which is CLIBE. And that will be presented by Nuria. So Nuria is an assistant professor at the UPC in Barcelona. And working for long in crowd simulation, computer animation. So I will let you go, Noria.
I go. Okay, I'll share my screen. Can you see the screen?
Yeah, we see it. Thank you.
Not sure how to. Okay, more or less good. All right. So as Julian said, I'm going to be presenting our project CLIPE, which started March last year, just after COVID, unfortunately, and it's about creating lively, interactive, populated environments. So we're looking at different aspects of generating virtual humanoids, whether it's for self-avatars or for small groups of avatars to interact with in virtual reality, or for large crowds of virtual humans. So this is a large project which involves 8 universities across Europe. So we have the University of Cyprus, where Yorgos Chrysanthou is the coordinator of this project, the Universitat Politècnica de Catalunya, which is where I'm working, Max Planck Institute, where we have Michael Black working on this project, KTH with Christopher Peters, the Institut Polytechnique de Paris with Marie-Paul Cani, Trinity College Dublin with Carol O'Sullivan, University College London with Anthony Steed, and INRIA with Julian Petre. And between these 8 universities, we have hired 15 ESRs, which are just PhD students working on this project. And because the goal of this ITM project is not only to prepare the students in their research activities, into being the next generation of researchers with experience in this field, but also to give them experience in the industry. We also have 5 companies that participate in the project. So we have Silver Sky for virtual reality, Treadis for scanning technology, BBC for broadcasting, Amazon for retail, Ubisoft for games, and Golem for visual effects. So the goal of this project, as I was saying, is we have in total 15 students hired by the 8 universities in the network, which have to be doing a PhD within that university, but with research visits to other universities of the network, and also one visit to one of these industry partners, so that they can learn how to turn their research ideas into a commercial product eventually. So across the training of these ESRs, we have different workshops. Some of them are more focused on research aspects, and some others are more focused on, for example, European Union funding opportunities, grant writing, career advancements. And also we have one focusing on industry-led entrepreneurship and just leadership and team working overall. So that's enough with the structure of this ITN network. Now I'll move on to the research objectives of our network. And basically what we're trying to do with this ITN project is to rethink the pipeline that we currently have for creating virtual humanoids and animating them and populating virtual worlds. So we are trying to develop new methods, new techniques, so that non-expert users could rapidly create virtual humanoids that can be easily animated and introduced into any virtual reality application. So we're looking at the generation of meshes for virtual humanoids, but we're also looking at the animation of those virtual humanoids. So for example, the second research objective is learning interactions with virtual characters. So it would be ideal if instead of having to script the behaviors of these virtual humanoids, we could have virtual avatars interacting with us, for example, in a virtual environment, and have those virtual avatars learn from our movements, learn from our behavior, and also learn to react to what we do, so that they could, for example, show surprise if we scare them, for example. Have virtual humanoids that we can, for example, identify by their walking style, because they have styles assigned on top of their animations. So those are some of the aspects at the individual avatar level. But then we're also looking more generally at the general crowd simulation. So anybody who's ever worked on crowd simulation knows how time-consuming it can be to have all these virtual avatars behaving, not just moving around others, not colliding with each other, but also providing them things to do in the environment, goals, things they have to do, places they have to go to, and get the overall crowd behavior to make sense from a high level point of view, not just from local movement and collision avoidance, as I was saying before. So again, we're looking at ways of being able to author these environments or to even populate these environments in a more natural way without having to script absolutely every behavior that these humanoids are going to be doing in the virtual world, and maybe have specific roles that go with specific behaviors. And finally, of course, if we're working with virtual humanoids, whether it's individual virtual humanoids or crowds, and whether we're working for virtual humanoids for virtual reality or augmented reality, the ultimate thing we always need to do is to actually test that the avatars appear realistic and behave in a natural way from the point of view of the user. So we have to be, of course, careful with uncanny valley issues in this kind of work. So all the different experiments we're doing through the network, we are also testing them in virtual reality and studying how the user perceives them. So I'll now go very quickly through a few of the preliminary results we're getting from the network. So I'll introduce briefly, for example, the work by one of my students at the Universidad Politecnica. And then I have 2 videos by 2 other students from this ITN network that have prepared a 5-minute presentation of their work. So you can see the results we're already having. So my student Jaura and June, together with José Luis Pontón, another of my students at UPC, are looking at the different aspects when it comes to animation of self-avatars for virtual reality. So as you have seen in other presentations today, for example, if you use the XSense mockup system, you can get very accurate animations. However, not every lab can have a mockup system at home. So ideally, we want to be able to animate these self-avatars with just a few trackers, like you can have here with the HTC Vive, the controllers, and maybe an additional tracker on the root and maybe the feet if you can. And as you see in these examples, the animations you get with this, with a few trackers and IK are not always correct or are not always as good as the ones you get with the mockup system. So the problem is that if you're using these animations for your self-avatars, you can notice these misalignments between your self-avatar and your own body. So we're looking at ways of learning from mockup data, from ground truth data, to see how we can get better animations when it comes to applying inverse kinematics with a few trackers. And the goal throughout all these projects is also to be able to have or to develop tools that can be then provided to the research, can be made available to the research community and the industry as open source tools. So for instance, one of the first things we've been doing is this Avatar Go asset for Unity that we're releasing now with this short paper publication, where we provide a quick setup for any user with the HTC Vive and a few controllers to get inside a self-avatars and through a really quick process have the avatar correctly calibrated and correctly following its movements. Of course, with the problems that IK still has that I was mentioning before, but having something that if you look in this camera where we have the see-through camera of the HTC Vive at the same time that we're rendering the avatar, we can see that the matching we get between the two is quite accurate. And this is mostly by simply making sure that we have a good adjustment between the offsets of the trackers and the different limbs of the body. Okay, so I'll go. We're trying to use these projects also for collaborative VR so that anybody could get this asset into their virtual reality application and quickly have their own self-avatars and they can be working together in these virtual environments. So this is an example on self-avatars animations.
We present icon.
Okay, now I'll leave this example from Max Planck Institute on obtaining characters from videos. And then we'll go to the last example also on animation. Oh, sorry. Sorry. Okay, no.
We present icon. ICON stands for Implicit Clothed Humans Obtained from Normals. ICON robustly reconstructs 3D clothed humans in unconstrained poses from in the wild images. This enables the creation of avatars directly from video, with pose-dependent clothed deformation. Current methods for creating such an avatar require various posed 3D scans as input. Yet 3D scans are expensive and are not accessible to common users. State-of-the-art clothed human reconstruction methods are a promising alternative. These aim to recover almost scan-quality 3D human shapes from a single image. By feeding these reconstructions to avatar creation methods, it is possible to create avatars from monocular videos. However, current reconstruction methods often fail on in-the-wild images. This results in 3D surfaces with broken or disembodied limbs, missing details, or non-human shapes. The main reason for this is that such models are trained on datasets with everyday poses, for example, render people, and do not generalize well to unseen or extreme poses. Hence, we propose ICON. Let's first look at why previous methods are sensitive to pose variation. For the input color image or voxelized body, these methods typically apply a deep 2D or 3D encoder and feed the extracted pixel-aligned features to a reconstruction MLP. During inference, the network might see poses that differ from the training poses. Such global pose difference may lead to dramatic change of pixel-aligned features, leading to poor reconstruction. In contrast, ICON uses local features. ICON takes as input an RGB image of a segmented clothed human and a simple body estimated from the image. The first one infers detailed clothed human surface normals. The other one, together with the clothed human normals, regresses the surface using an implicit function. This has a key difference compared to existing work. There is no global encoder. All features used by the MLP are locally defined or queried. During inference, the clothed normals and simple mesh can be refined in a feedback loop iteratively to reduce pixel-level misalignment introduced by HPS. Here are some comparisons with other state-of-the-art methods, including PyFu, PyFu HD, and Pamir. These methods are not robust against challenging poses and out-of-frame cropping and result in various artifacts. On the contrary, ICON generalizes well to these out-of-distribution scenarios and produces high-quality results. With ICON, it is possible to collect many clothed human shapes in various poses from in-the-wild images. Here are more qualitative results on extreme poses such as dance, kung fu, parkour, and sports. Please note how robust ICON performs without training on such poses. Such a dataset could help research in human shape modeling and be valuable to downstream applications. We show an application for easily creating animatable avatars. As input, we get a sequence of images containing the same subject in various poses. We first reconstruct a 3D human shape from each image. Because the reliability of ICON's reconstruction is view sensitive, we only feed the visible parts to Scanimate to create a realistic, animatable clothed avatar with full texture. The resulting avatars have a realistic shape and clothing deformations. Note that clothed deformations are dependent on the actual poses. Our models and code will be available for research purposes. Thank you for watching.
Okay, so this is the example on generating avatars. And now we'll move on to
Hello, my name is
the next
Eduardo,
one.
PhD student at Polytechnic, and in this presentation I will introduce some of my work in the context of CLEP, our PhD program. The design of plausible animations is a key task for many applications. They are essential to provide realism in computer-generated films or to create reactive characters for video games. In my topic, I am considering the precise example of authoring animations in natural environments, where a wide range of elements can alter the character's behavior, from the ground irregularity to vegetation. Moreover, the challenge of modeling such a range of animations is also due to the reciprocal nature of such behaviors. For instance, a character that modifies its gait when it walks in deep snow. Finally, I focus to optimize its process for real-time applications, while we further decouple technical knowledge from creative productions by creating authoring tools to generate expressive animations easily. To achieve our goals, we are addressing the problem at different levels, such as for local interactions between the character and the surroundings, as well as from an individual scale perspective, and also finally, large scale behaviors. In our first work, presented as a short paper for Eurographics, we introduce one idea to address the problem of two-way real-time interactions between characters and natural environments at an individual scale. For this method, we implemented a global controller to provide a self-balanced behavior to the character's gait. At the same time, we perform a recasting method to procedurally carve the footprints on different terrains. Then an inverse kinematic system makes the character adapt its gait automatically. Finally, we modeled also the impact that loose elements like vegetation may have on the character's movement by using a system of procedurally controlled platforms that simulate the inaccurately perceived ground by the character. In our second work, we extended the idea of having a more accurate real-time terrain deformation to enable two-way interactions. Our new system considers now the dynamics of the character, its morphology, and the terrain parameterization to procedurally deform the ground based on the character's motion. First, a lightweight force model estimates the forces exerted to the ground from an arbitrary animation, for example, mock-up data. Then, a deformation model maps the pressure into a ground deformation by considering the material parameterization, such as the time it takes to absorb the impact, its compressibility, or the amount of vertical displacement. As a result, the system is able to successfully generate less pronounced footprints for letters, for example, or deeper ones when they are stepping faster, while an inverse kinematic layer modifies the motion based on the ground irregularity. This work has been published in the journal Frontiers in Virtual Reality Technologies this year. But how can we now further improve the ability of virtual humans to react with its surroundings in real time? In my current work, I further researched on a new layer of authoring for the upper body that improves the real-time interactions of arbitrary animations by controlling the stiffness or relaxation of the upper body limbs in an intuitive way. While fully physically based characters are costly to train and control, we decided to create a system to adapt the influence of physics for each individual limb given an arbitrary animation input, enabling you to have the best of both worlds, controller-based and kinematic-based animations. Then an inverse kinematic layer is used to drive the kinematic motion and accomplish a user-defined goal, for example, stopping any incoming object into a region around the character. Finally, we developed our own reformulation of antagonistic-based controllers to drive the physically based limbs and match their kinematic counterparts. Unlike other types of PD control, this technique decouples stiffness and position control for each degree of freedom independently, allowing us to model the amount of relaxation or stiffness individually for any given target orientation. As a result, this method is able to enhance the reactivity of upper body motion in real time by introducing local stiffness control for each joint, thus achieving a greater biological plausibility. This technique can also be applied to other types of arbitrary animations, such as mock-up data. Even in the case of fast movements, our system is able to efficiently track a target animation in real time, while adding physical coherence under external perturbations, based on the relaxation or stiffness state of the character. Thank you.
Okay. Okay, so that's the work by three of our students, and that completes my presentation.
Thank you very much, Nuria. So we are few minutes after schedule, but we can have one burning question maybe or two to Nuria. That was clear, just
clear presentation.
Clear. So thank you. Yeah, that does make. Let me say also that there is part of the CLIPE results which are to be presented at IEEE, like the one-man crowd paper will be presented there. Also some paper by Pierre. Yeah, so a couple of papers to be presented here at this conference. Okay, Katya, should I let you introduce our third speaker for this session?
Sure, thank you, Julien. So this will be our last talk of this session, and it's my pleasure to announce our final speaker, Donna. She's going to present the Motive project. And just a little bit about her. So Donna is a postdoctoral researcher at the Event Lab at the University of Barcelona and part-time lecturer at the Universitat Oberta de Catalunya. She combines technical expertise and experience in research methodologies to understand and promote the use of virtual reality in the fields of psychology and cognitive neuroscience. And she has given invited talks at esteemed international scientific meetings, and her research has been featured on major media channels in Spain and abroad, so BBC, The New Yorker, The Psychologist, and she also has a documentary film in her resume. So great to have you here, Donna, and the floor is yours.
Thank you, Katya. I'm happy to be here, and thank you all for attending. I think you can see my presentation. I'm just going to go in full view. And yes, I will be presenting the Event Lab ERC project Motive. Motive stands for Moments in Time in Immersive Virtual Environments. And the aim of the project is to research how virtual reality can be used to recreate historic events and give people the perception that they are really there, thus addressing the concept of place illusion, virtual reality, but also to perceive the what's happening, the events as real, and therefore addressing plausibility. And so to provide a platform on which we base the research, we are focusing on reconstructing famous rock concerts from the 80s and early 90s. And the specific elements of the research include agent-based models that eventually populate the environment with thousands of agents whose behavior is driven by the music, in the case of concerts. And the ABM will also embed the participants as a type of agent. And thus all agents, including participants and the virtual characters populating the environment, have their own personality. They can have their own emotional state. They can influence one another, and eventually the actions of the participants and other agents can also impact and influence the unfolding of the whole scenario. Like I said before, one of the goals of the project is to address presence, place illusion, and plausibility, but with the goal to develop measurements that can be used universally in virtual reality scenarios to really capture the idea of presence rather than relying solely on self-reports such as questionnaires or, for example, physiological data, which is the most common ones that are used nowadays. I'm going to present relevant study right after to give an idea. Of course, the participants are embodied in these scenarios. They have a virtual body, which they can experience from a first-person perspective, and the virtual body will move and can move as they do. And thus, we're exploiting the concept of body ownership illusions to see how participants' attitudes and behaviors are affected in these scenarios, but to also address agency. And from our past research, specifically illusory agency, and for those who might not be familiar with this concept, illusory agency refers to actions that we attribute to ourselves, but we did not explicitly perform ourselves, but rather our virtual avatar performed, but then we do have the perception that we performed a specific action. And in the case of this scenario, for example, we will be exploiting this to see how we can improve motor learning, for example, with regards to playing a musical instrument, since we're talking about concerts. And finally, since participants will not be restricted and they can freely move in the concert scenario, not just inside the concert, but for example, heading towards the concert, coming out of the concert, meeting up with others and so on. We will be looking at navigation and other sorts of interactions. And we will exploit some basic principles of embodiment, some multisensory principles of embodiment to address some of the problems that we face in virtual reality, such as that of simulator sickness. So this is an example of what my colleagues at the Event Lab have been working on. We are recreating the concert by Dire Straits from '83 at Hammersmith Odeon in the UK. So relying on material from that era, from the 80s, that's mainly DVD or other video material. The aim is to automatically reconstruct the both the characters involved in the specific scenario, but also the actions, in this case, the performance of the concert. And this is what we have in virtual reality. Well, it's one of the versions, because we continuously updating and improving the whole experience, both with respect to the bands performing on stage, but also to the virtual crowd that is eventually surrounding the participant to give them the impression that they are really there. And this is an example of what we currently have and what we have recently used in a study to measure presence in this context. So very briefly, in a study that we conducted online, it's actually two studies, a pilot one and a newer one. Participants went through this concert experience scenario. It's about a 10-minute experience. And it was done with students mainly from universities around the world. And right after the experience, they were asked to write a very short essay about it, concentrating on their feeling, for example, being at the concert, on how much they moved along with the crowd around them, for example, the dance, clapping, cheering, and so on, telling us about aspects that drew them into the experience and aspects that drew them out of the experience, and anything else that they wanted to comment on. And these were also paired with some typical questionnaire responses that we collected, such as the perception of being at the concert, how much they felt like being in the presence of others, and so on. The analysis was done following sentiment analysis. I'm not going to go into the details, but it's mainly used based on dictionaries, and you can think of it as classifying sentences having a neutral, a positive, or negative sentiment. And the results were very unexpected, but quite interesting. Mainly with respect to the plausibility aspect of presence. And to be more specific, For example, participants reported the sensation of being alone, but not with respect to co-presence, not with respect to the crowd surrounding them, but with the but regarding the fact that they attending the concert themselves, whereas in real life situations, this is something they usually attend with a friend or with a loved one. But that's a quite interesting. That's quite interesting feedback. But it's also something that can be very easily tackled, and by supporting multiple people to simultaneously attend the concert, which is something we are currently working on. Also, since we did have a crowd, and it is one of the factors that we are looking at and manipulating in this specific example, we designed the characters around the participant to stare back at the participant when they were looked at. But the majority of them reported that perhaps they were being stared at by the virtual crowd for way too long, and some of them felt really disturbed. And while that implied negative sentiment, it also means that plausibility was quite high in this case, because plausibility does require you to really perceive yourself being there, thus feeling disturbed. Otherwise, what's the reason of being disturbed if you really did not feel like being there and the others were looking at you? Another interesting finding was that the audience members were reported not interacting with the participant other than being looked at. So they were expecting more interaction among the virtual crowd, but also between the members of the band and the audience, which is something that usually happens in real life concerts, the band interacting with the audience below. They reported a lack of diversity of the crowd, but that was something that we specifically designed for that experience, but it was noticeable. Very interestingly, it was reported that the clothing of the virtual audience and their behavior did not match the time at which the real concert took place, at least for those who had attended the concert in '83. So that's another good example of the importance of plausibility in virtual reality, and how oftentimes, in contrast to place illusion, which is a bit easier to address, plausibility is something much harder to identify. There were other technical problems. Sometimes, for example, there was a lack of synchronicity between the movements of the crowd and the members and the corresponding sounds, or the performance of the band and how they were playing the musical instrument, which again is something that we are trying to improve as the technical side of the project improves and moves forward. The audio aspect was something that was considered well, so there was specialized audio. But nonetheless, because, for example, we included the feedback from the crowd, the cheering and everything in one audio file as the music. So participants reported, for example, they would prefer listening to people close nearby speaking louder than those further away, and so on. The important part of this experiment was that if we relied only on questionnaire data on presence, which is what we're doing now, we wouldn't have discovered all these underlying issues. But important aspects that help us will now help us to improve the experience. So we're taking all this feedback into account for the next version of the concert, of the next experience, and so on. And of course, like I mentioned before, sentiment can be different, and it does not really mean that if you have low sentiment, then your presence is low. One does not lead to the other. You can have high presence, but sentiment can be low. You can have low sentiment, high plausibility. It really depends on how you want to design your experience and what your experience you are implementing, because in some cases, such as when you are working on psychotherapy, you probably want your sentiment to be low in contrast, in a rock concert, you would expect the opposite, so you need to design it accordingly. Like I mentioned already before, the disturbed participants mean that there was the aspect of the concept of plausibility in the environment. Otherwise, why would you report being disturbed? And of course, yes, I mentioned it already that it was a very helpful method for us to gather information that helped us improve the application. And it's something that can be really used in different contexts, not specifically in this one. I'm not going to talk any further. I'm just going to say, oh, my title disappeared there. One other aspect we are working on now is, all this example was of you being a participant as a member of the audience, but of course we are in virtual reality, we can do whatever we want. So why not be on the stage with the band, performing with the band, or performing as one of the members of the band. And yeah, this is my face here on top of the face of Mark Knopfler. It's a bit strange maybe, but just to give you the idea, right? I can be whoever I want. So the long term of the project is really to understand how we can capture these treasured moments in time to give people the chance to either relive them if they have lived them in the past and they would like to go through it again, or give them the opportunity to live them for the first time ever. If, for example, you were not born back there, you don't have the chance to be at the specific concert and you would like to attend it now. And thank you very much for your attention. This is a very kind video that my colleagues passed on. It's the members of the motif, and since we're talking about concert, this is all of us dancing together.
Excellent. Thank you so much. Thank you for this nice presentation. We have maybe time for one very quick question because we're moving straight to the next session, I believe. So if there's any questions for Domna, please don't be shy. Daniel.
Yeah, so right now this whole experience is offline, right? So when you plan to have multiple users, will there be like a voice chat feature so that they can talk about the experience? Or do you think that's like too distracting?
No, we are actually trying it right now. We do have it set up. I've tried it with my colleagues. You can attend the concert simultaneously with somebody else. It gets harder the more people you add. Of course, there is a technical aspect, but from my personal experience right now, it is quite interesting. I did not expect it. It does really feel like being in an actual concert. And I was here at home the other day having my headphones on, and I was trying to speak to my colleague, and I was literally shouting in the living room. And my parents I'm staying with my parents right now. We're really worried what's happening, why are you shouting? But you are at a concert, you need to shout, right? Really loud. We are working on that, and hopefully we can test it with more people soon.
Sounds good.
Yeah, thanks.
Thank you, Daniel. Okay. If there's any more questions, please leave Domna a message on Discord. And I think we are going to move now to our last session. Is that correct, Anne-Hélène?
Yes, that's correct.
Oh, Andrea.
No problem. Thank you, Katja. So now it's finally time for our cross-community panel, and we are very happy that our three panelists, Anton, Dinesh, and Nicholas, accepted our invitation to speak here today. And then, as I can see, the three have arrived safely here on Zoom, so we can start. That's great. Each panelist will give about a 10-minute insight into his research, and then we are looking forward to have an open discussion with many questions from the audience. So for this, feel free to ask questions via Discord throughout the panel presentations, which we will then read out to the panelists afterwards, or raise your hand in Zoom during the Q&A part to ask a question live. So, and now let's start. It's a great pleasure for me to introduce a dear colleague and our first panelist, Anton Bogdanovic. And perfect. So Dr. Anton Bogdanovic is a senior lecturer of entertainment computing and applied artificial intelligence at Western Sydney University. and he's also the director of the academic program for technology entrepreneurship. Anton's research is predominantly focused on virtual reality, interactive 3D visualization, and artificial intelligence. Apart from his academic work, Anton is also the technical director of Art On Lab, a virtual reality and 3D visualization company. One of Anton's key research focuses is historical reconstructions. He built reconstructions of ancient Mesopotamia and the settlement of La Drago in Spain, and of course, all populated with virtual agents. His 3D simulation of the city in Uruk, 3000 BC, also or even won bronze in a prestigious international artificial intelligence contest organized by the US Army. Anton was the organizer of top international conferences in the field of virtual reality, such as VHCIE, which probably most audience are familiar with, but of course also in the field of virtual agents like the IVA. And with this, again, a very warm welcome, Anton, and the stage is yours.
Yeah, 1 second. Hello, everyone. Just struggling a little bit. For some reason, I'm sharing my screen, but do you guys see it?
We see the main slide, so everything.
Oh, okay, cool. All right. So yeah, hello, my name is Anton. Thank you for the introduction, Andrea. The purpose of my talk is just to give a quick overview of some of the key projects where we use virtual agents. The whole virtual agent journey started for me a long time ago from creating historical simulations. What you see on the screen right now is one of the latest simulations we've created. This is reconstructing everyday life in the early Neolithic settlement of La Draga in Spain. So the idea is that we take the data from a panel of expert archaeologists, historians, and just show how this place used to look like, and also show what people did, and etc. So every single avatar there, we spent months and months polishing and thinking on every piece of furniture. So everything is 100% authentic. So we knew which people remains we found and which jewelry we found. So everything comes from the actual historic site, reconstructed. Before that, one of my big projects was reconstructing everyday life in ancient Mesopotamia, city of Arak specifically, at a bit of a later time. So here is one of the simulations that we see here. We reconstructed it in different periods. This one is from 5000 BC. We also had 4000 and 3000 BC. And we also created Aboriginal simulations. I'm from Australia, so this is what our university campus used to look like in Aboriginal times, as envisaged by the elders that we work with. We managed to put some of our Aboriginal elders in motion capture suits and record some of their rituals, and then simulate it to wider audiences. But yeah, so along the way, we developed some pretty cool technology and published widely about it. Just to give you a very brief overview, behind each such avatar, we have this big tool where each avatar is driven by something like Maslow's pyramid of needs. We simulate their desires, generate goals as a result of it, so that agents get hungry and thirsty, etc. There is a set of social norms that applies, that restricts their behavior, and each of the agents has a particular role in the society, and as driven by their goals and desires and restricted by social norms, the agents decide what to do, and they start eating, sleeping, and working, etc. And we can simulate large crowds of agents doing all of that. Now, my current focus is more on medicine, on healthcare. This particular example is medical training for anesthesists, where there is a virtual patient and a virtual assistant that runs around and helps, assists and brings certain objects, connects the patient to oxygen, and does other kinds of medical assistance that you require. We also experimented with non-human virtual agents. This particular one is a psychological intervention to help people with chronic pain. So we work with clinical psychologists. If you have chronic pain, there are really two ways to treat it. You can heavily medicate people, and there are obvious consequences of that, but there is very good psychological intervention where what happens is you're working with a clinical psychologist, and if you're rigorously doing this training, your pain can substantially decrease. And say if you started with sharp pain coming at 9 out of 10 kind of ratio, then you would end up with lowering it to 5 out of 10 or something like that. So the pain will not completely go away, but we can train you how to lower it, and we can train you how to avoid the spike. So we took this training into virtual reality. We visualized the pain character as this spherical looking guy that keeps changing its appearance depending on how well you are progressing with the game. So the more you relax and the more you follow the training, the least annoying the pain character will be, and the more appealing it would look. We've done some also work with the same pain character and with some additional virtual humans for other pain relief techniques, such as progressive muscle relaxation, helping the user in virtual reality to follow a set of exercises that ease some localized pain. Like say, if you have a stiff back and it really hurts, there are some exercises how to help you relax all your other muscles, and then your pain will also reduce. We've done some fun work on rehabilitation and using virtual agents for that. This one was specifically developed for our top BMX rider in Australia. Sadly, he had a horrible crash as he qualified for Olympics in Japan, and he was in coma for a while, and then he had a severe brain injury and needed rehabilitation, but he had almost zero motivation to exercise. He really struggled. They would put him on a bike, ask him to go really, really hard, but he had no interest whatsoever. So we developed a motivational game for him where he is riding against his sister. That's him, Kai Sakakibara. And it really, really worked. So he was really keen. He was screaming. He was going really hard just because he was there riding his virtual sister on the track. Another project in this direction is training clinical psychologists. This guy here is a virtual patient that you are to treat. And at some stage, this patient gets into a panic attack, and you have to figure out how to handle it, how to correctly proceed with your intervention rather than completely abandon it. So yeah, witnessing a panic attack in VR is quite frightening. So we are running the study right now, seeing how it affects people and what kind of decisions psychology interns make as a result of this. And the final direction that mainly comes from the business side of things rather than from research, but I'm trying to combine business and research whenever I can. So whatever we do in the business, we also publish papers about and get other researchers on board. So this one is real estate, simulating a street that is not yet developed and populating it with virtual agents that pretend to be people that live there, so that people walk around in VR, select a house, and see how their neighborhood is going to look like. Yeah, so that's it that I have for today. Just a brief overview. If you have questions, I'll be waiting for them. And thank you for having me.
All right, great. Thanks, Anton. With this, I hand over to Anne-Hélène to introduce the next speaker.
Yeah, thanks a lot. And we will move on some crowd topic with Professor Dinesh Manosha. So Professor Dinesh Manosha is a Paul Chrisman IRIB Chair in Computer Science and a distinguished university professor at University of Maryland, College Park. His research interests include virtual environment, physically based modeling, and robotics. And his group has developed a number of widely used software packages licensed to up to 60 commercial vendors, and he has published more than 600 papers and supervised 40 PhD dissertations. So it's kind of impressive. And he received the Distinguished Alumni Award from IIT Delhi, Distinguished Career Award from Washington Academy of Sciences. So Dinesh, if you want to share your screen, please.
Thank you for organizing a wonderful workshop. It's good to see. I've been hearing all the talks for the last 2.5 hours, and it's a great for you and Julie and everybody else to organize the workshop. Can you let me put my slides up? Can you see my slides?
We can see your presenter mode, not the main slide. So
how about now?
Yeah, perfect.
Okay, great. So thank you. This is thank you for the wonderful workshop. So my group, I was at UNC and I moved to Maryland about 4 years ago. So we have looked at a lot of problems we have been hearing in all those wonderful talks for the last 2.5 hours, on VR, avatars, and recently the European project. So I'll just give a brief overview of what we have learned about simulating agents, avatars, and crowds over the last, I would say, our group has been working for the last 13 years. So first, we're working on the problems of simulating large crowds, large number of agents, how they interact. And of course, they're games, but our work is driven by like real world scenes. Like on the top right, you'll see, some video of a panic attack comes, how people will do. On the bottom right, you will see some stadium evacuation. And then we had a project with Boeing, Boeing want to know when you fly and load and unload the airplanes, what's the best strategy and how do you do it? So these are a lot of applications from, real world crowd scenarios, evacuation, or even airplanes where pedestrian movement was things. So we did a lot of work. Some of my collaborators also here. I work with Julian's group and many other people here. And this, as I said, this technology is used all over the place. If you look at the latest game engines like Unity and Unreal, they have some version of a method we call RVOs, and it was licensed. Some of the games, this is now almost 7-8 years ago. At that 7-8 years ago, dealing with large number of agents was a big challenge. Today, it's not a big deal now. And this was the first game, the Warhammer, coming in 2013, which actually took these ideas together. Besides, doing all this games and this thing, there's a lot of real world situations. So in between 2011 and 2014, we had a collaboration with a group in Saudi Arabia, Mecca, Hajj, where, of course, right now, last year has been COVID year, so there are not too many crowds, but there are too many crowd disasters. This is a religious event where people get together. I don't know if you can see my video well on Zoom. On the top is a simulation of real Hajj. You see the Holy Kaaba, and near the Kaaba, the density is about 8 or 9 people per meter square, and they have had disasters. In fact, there was a disaster in 2015, not in Kaaba, somewhere else. There were other disasters like, on stadium and this thing. So we bring the technology on the bottom, how we can simulate dense crowds and things that evaluate like what you see, the density and the movement, how you can do design. The ultimate challenge was, how can you change the layout of these big structures so that crowd movement is smoother and you minimize disaster, which is still, I would say, a big open problem because, we don't have very good technology for simulating very dense crowds. So when the crowd becomes so dense, it becomes challenging. So about 5 years ago, we took a lot of ideas. One of my students, Sean Kurt, is the development of what we call Mange, which is an open source system where we release a lot of this software package. You can plug and play, global and local. And Sean has been maintaining that even though he graduated about 5 years ago. There's a big user community using this crowd simulation. It also integrates with Unity Wrapper and ROS if you're a robotics background. So at least the community is using it, building more and more model comes up, things go there. Then about a few years ago, I had a student, Aniket Bera at UNC, then he's a research scientist at UMD right now. We started looking at real world crowds, because what has happened in the last 7-8 years, a lot of videos are available and computer vision and machine learning had advanced to a level that now we can do a lot of tracking, something which was considered difficult 10 years ago, but we can do now. And today you have pretty good solutions based on deep learning, which can take these videos and track it. So let me just show you this. This video is about 4 years old now, but this was, using Aniket's work on using a Bayesian optimization-based formulation. But you could see, this was real-time tracking, and we're getting pretty good thing. And as you can track a lot of real-world crowds from the videos on YouTube or other sources, you can literally get a lot of information about their real-world movements, because modeling real-world challenges is always a pain. So we start analyzing a lot of things like how people move. Can we predict their trajectory, which is useful for many applications? And can we also figure out human behavior? So this is some more dense crowds we did. And later on, we try to also do some prediction that some people in this crowd are dense, some are aggressive. So this area has matured a lot. I would say last 5 years, you'll see more papers in computer vision community where people do a lot of pedestrian tracking, trajectory prediction, and now there are lots of deep learning models which are widely used. So it's good to see that we can take real world videos and do things with it. So this is another one of those, I'll see if I can show the results here. So this is some other work we did. Basically, not only we track them, but how people move in a dense crowd. We also try to analyze their, personality, whether they are a little bit aggressive, active, or shy, And this is very interesting to see, because if somebody's aggressive and your autonomous car, you will let them go, and somebody is shy, you don't. So in real world, when we walk, we look at people around you and we try to estimate their personality and affects our motion. So we're trying to do the same technology here. Now, what has happened in the last few years, there's all this excitement about, first, it was called social VR about 3-4 years ago. And nowadays, since last October, everybody's talking about some version of what somebody called metaverse, somebody called omniverse, and you see a lot of media attention. Whatever it means, the idea is that you're in an immersive setup, possibly with some AR or VR glasses, and your avatars or social avatars. So now there's a new interest on generating realistic avatars. There are a lot of companies coming up. They still use very Cartesian avatars, but you can see a lot of packages on the websites where you can be in some setting instead of Zoom and doing interaction with avatars. So this recent interest has actually given rise to new kinds of VR application. And one of the group my students have been doing first at UNC and UMD, this was a paper we got the best paper award, that not only when you generate motion, but you also generate motion of your agent avatar, which conveys, some emotive gestures. Like on the right, if you're like happy, you walk in your arms, in certain manner, and your gestures also. So you express your emotion with the way your body gestures move and how you do it. So not only you want to generate realistic avatars, you take your visuals and reconstruction, but you want to convey emotion, because emotion is a very important component of how you talk in the physical world, and can we do the same thing in the virtual world. So this is also different movements, we try to simulate here, where certain movements convey you're happy, certain when you move your head down convey you're sad, certain movements and gestures convey you're aggressive or angry, and some are neutral. So we've been looking into also, especially generating agents or avatar full body motions. And this is still quite challenging because, humans are very subtle in their movements, and, and how do you do the body movements, which is high degree of freedom. So these are still in many ways early results on that. This is an area, as we have virtual agents avatars, we can expect much more interest coming up.
How do I look?
Here's an example of a human talking to a virtual agent, and virtual agent
But I
conveying
can't go out. It's been raining all day.
That's very tiresome.
Yes, it's very damp and gloomy.
And cold as well.
And the pandemic is still at large anyway.
I hope we get over this soon.
We will if we all do our parts.
And have a kind heart and be willing to share our concerns.
So this is, we're entering an era where a lot of AI technologies, are coming together. NLP, conversation agents, we're seeing more of that, and Alexa's and Google having conversation agents. But when we talk to the current agents right now, all we hear is the voice. We call it the God's voice, but there's no person. But imagine there's a realistic agent whose actions convey the same emotions. You're having conversation with a virtual agent, but the virtual agent has the same tone, same gestures, like I'm talking with my hands movement, same body language, same thing. So this is becoming nowadays a very big challenge in all kind of communities, that how can we generate virtual agent avatars which not just sound real, but have realistic action. So this is where a lot of AI technologies are coming together nowadays. So this is some work recently Aniket has been doing at UMB.
I'm your artificial intelligence-driven virtual conversational assistant. I can help you with daily chores, tasks, and will be able to make smart conversations.
My gestures, facial expressions, and speech are generated in real time using state-of-the-art research in effective computing, emotional modeling, character and speech generation, and virtual reality.
I was designed at the University of Maryland. I can not only speak different languages, but can also generate cultural and emotion-sensitive gestures and expressions.
In the future, I will be able to understand you better, learning from you and your emotional states.
Approach is a transformer-based learning method to interactively generate emotive full body gestures for virtual agents aligned with natural language inputs.
Would you please follow us in our social media to stay involved and informed regarding the development of our project? Thank you.
So you can still see, well, this work is promising, but there's still a lot of challenges. And one of the biggest challenges in our daily life is that our faces play a huge role in conveying our emotion. Somebody's happy or sad. And right now, even in the video I showed you, the faces were kind of dull, and not very, very, very emotionally powerful. We can gestures well, we can do body movement, but faces, even your eyes, your expressions. So this is still a holy grail, that how can we generate faces of agents and avatars which can convey emotions. So a lot of research is happening in the vision AI community, and I think we can expect a lot of excitement in the coming years. So this is again, as I said, not just saying, but the whole body language. As we deal with people in real world, we don't realize how much the body language we do. And as we add these agents avatars in the virtual world, the so-called metaverse or whatever application media talks about, how do you get involved? And I think the emotions and the body language is a big part. And this is, I would say, still a very big open area where we can do better. Besides all this VR, there's also recent work on robotics. Robots are getting very odd. And some of the work we are doing is, there's a robot automated navigating, but this is a robot navigating among crowds. I've collaborated with my student, Japan, who's a professor in Hong Kong. And I said, take the robot to the fish market. So using a live video, in this case, if you look at, we do real-time tracking of crowds, and the same kind of model we did, RV and deep learning models, but the robots on the left are doing it, on the right-hand side, a different kind of a robot, which can do. So some of the same ideas we're doing in simulation, vision, machine learning from VR also applies to robots. And one last thing, as I said, there's a lot of work recently on generating rendering. We saw some talks and motion, but it's high time we dress up these agents. So one of the technology we've been working for many years is simulating cloth, and cloth is now coming to a stage we can real-time simulation. So this is all over the place, clothing, fashion. And one of the recent places where we did, this is one of my student and former collaborator in China, Mintang. We have a social media app, where you get realistic cloth, because this is a cloth, you can see the skirt moving. So this is cloth simulation happening on the server using physics-based simulation or learning methods. But again, this is one of those things, if you can dress up these avatars or agent with realistic cloth, it changes your perception. So we're entering a very exciting time with all this, maybe hype or investments in metaverse, VR. We all want our agents, avatars. We want to convey the emotion. We want to look real. We want to dress real. We want to walk real. Bring everything together. And there are plenty of problems which can keep us busy for 5-10 years. So we'll just stop here. I hope I didn't go over my time. And any more questions I'll take later on. Thank you, everybody.
Thanks a lot, Dinesh, for this great talk. So I will give the floor to Julien, who will introduce our next speaker.
Yeah, thank you. Our next and last speaker for this panel is Nicolas Chavron from Golem in France. So let me read his bio. So Nicolas Chavron is one of the co-founder of French company Golem, where he works as a product manager. He is in charge of the vision and the development of Golem Crowd and Golem Layout software, a crowd simulation and layout tool suite for visual effects and 3D animation. honored with 2 Technology and Engineering Emmy Awards. Those are used by hundreds of high-end studios worldwide to simulate complex and controllable crowds in minutes. From the White Walkers of Game of Thrones to the Parademons of Justice League. So Nicolas, the floor is yours.
Hey everybody, can you all hear me?
Perfectly, yeah.
And see the presentation as well?
We see the slides, we still see a PowerPoint. Yeah, not the slides, okay.
So yeah, thanks for having me. So today I'm just going to talk about what we've been doing this past 13 years. So we've been doing crowds for, so M&E means media entertainment. So as Julien said, we've been involved into a film and TV series and production. So we are a software company. So that's 6 people composing the company. We founded the company in 2009 and we spin off from the INRIA. So we were, most of us were, PhD researchers, R&D engineers. And at some point we figured that we had all this tech, pretty great tech, which was only used in research. And we found that was probably a good idea to try to put this into the industry. So we took part of this technology and tried to make a product out of it. It took us a couple of years to figure what we could do with it, and finally we found a way with the cinema. And 8-9 years after, we started getting Emmys and that kind of awards. And by the way, that slide was not updated. We had a César from the French Academy as well, and a second Emmy pretty recently. So what we've been doing this past year, so we've been selling software to studios worldwide, which have been using that technology. So that's research prototype we put into a product, sell this into studios, and artists are using it to create amazing shots into this project. And probably rather than image, I just brought a couple of shots. It's not an updated reel, but that just gives you an idea of what people were able to do. So it goes from humans, animals, even the corn fields, and everything in the package, which means you can do battle, stadiums, city placement, and navigation, and so on. So I'm not gonna even toilets, which is a weird shot. So I'm not going to run the full demo, but just speak more about what we took from the lab and how we moved forward with this. So when we started into the cinema industry, we figured that rather than making your own software, it's probably a good idea to integrate with what already exists. So from day one, we decided to create kind of a plugin, and we kind of readapted this plugin to different platforms. So those are the logos of the main platforms that artists are using into studios. So you've got Maya and 3ds Max from Autodesk, Houdini from Side Effects, or Katana for Foundry. And we took some of the tech we took from the lab. We took like a research motion engine system. We took also a path planning and navigation system, and we had to build around this. So we kind of added also ways to make the placement of the characters, be able to combine the animation, then the navigation with some behaviors, and provide some artistic way to be able to drive your crowds. Obviously, when you deal with crowds, you want to have visual and morphological diversity. You want to be able to just bring one character, but be able to make variation of his appearance almost for free, have a variation of textures, variation of size, and have everything working correctly behind, which means when you change the size of the characters, you want the navigation and the animation to automatically adapt to this. You want the ground adaptation to take into account that the legs are going to be of different sizes, and so on. And finally, as people do crowds, which are more and more closer to the screen, you want to add all those more advanced effects, such as hair simulation, fur simulation, clothes. You want to also to have like physical collisions between the character when the density is too high. You want to have really that kind of impact when two characters touches each other. Or when you do a battle scenes and you got impact between projectiles and characters, you want to take also this into account. So we kind of build around the different leads that we took from the lab, and like make a product out of it. And it kind of looked, well, that's an early version of it, but it kind of looked like this. It ended up into something we call the behavior editor. So it's like a nodal editor where in the top left, you got a library of the different behaviors that you have. And the artist's job is just to, schedule those behaviors together, decide what you want to do for the duration of the shot. So right now he's saying, okay, I want to go somewhere. So I want to have a path planning system, which is making my character to go from point A to point B, taking into account the environment. I want to adapt a locomotion animation on top of this. So let's suppose this. We have like motion graph kind of system here to be able to, let's replay the video, sorry. To adapt the animation properly, you also have like procedural layers such as look at and be able to do some I keys on the limbs to be able to grab some objects. And finally, all those behaviors are going to be triggered by conditions. So the artist can decide when I'm close to a target, I want to stop my animation and play another one. When I'm colliding with another character, I want to play a physical behavior. When I'm close to a target, I want to trigger a look at behavior. So you just like schedule those behaviors, run the simulation until you end up with the right results. So that's what the studios are using right now. And I just also brought an example which shows how you can put this into a single shot. So you get characters gathering and creating a formation. You got people just playing a motion clip, people randomly playing some clips. So everything you can see here in the shot is just a matter of scheduling different behaviors, arranging different behaviors and assigning them to different characters. And if you're not happy with the default behavior blocks that we provide, you can still extend the library yourself. So we kind of also brought a visual programming language where you can make your own navigation algorithm. So we provide a state-of-the-art navigation. Every year we read the SIGGRAPH papers, we figure which one are the best in terms of artistic control, provide this into the system. But if you want to extend this, you can also build your own system. So we provide, the perception building blocks. So each entity perceive what's going on, in front of them, on the left, on their right, how fast the characters around are moving, and they can decide to experiment and create their navigation algorithm themselves. So that's a Game of Thrones shot here. That's one of the customers which was, kind enough to share the scene with us. And you can see here the horses, they're seeing like from really in front of them, like really far in front of them, which allowed them to make lines and create that really nice pattern. And locally, they're also avoiding the other horses and cavalry soldiers which are next to them, just by slowing down or moving on the left, on the right, depending on this. So that's for the media entertainment. We've been doing this for almost 10 years now. I've been working, on a lot of amazing projects with hundreds of customers worldwide. And we figured that now the technology has become mature enough that maybe we can try moving into a different market, like extending our offer. And as Dinesh also mentioned, synthetic data is kind of a new and a big challenge for everybody since a couple of years now, and we could already see some customers coming using the software to create synthetic data, but we figured maybe we can provide more data to this. So it's using the same building block, the same plugin, but rather than integrating into media entertainment platform, there's also some platforms which are dedicated to synthetic data. So one could be Unreal Engine. We can see a lot of people using this. And recently, NVIDIA also released this platform, which is called Omniverse, which also allows to combine plenty of different texts and have real-time rendering of a lot of characters and objects. So that's this is here going to be the just a demo that we made ourselves. So you can see we are not artists; we are mainly a team of engineers. So that's kind of the best we can get in terms of visual appearance. But that's just to show that within the same tech integrated into a platform, another platform, you can just create hundreds of variations of the same scene just by changing a couple of random parameters. You can just set up your behaviors to your entities and let them leave the simulation for how long they like. And as it's synthetic data, it means that we've got the label of everything all the time. So we can say this is going to be a man character playing this animation. This is going to be a woman character playing that animation. She is wearing red t-shirt and so on. So you don't have to label the real data. You can just create this and use this to train your model and maybe combine the two data together, having synthetic data, but also real data to learn the different layers of your model. And yeah, that was it for me.
Thank you so much, Nicolas. So now we are really in the last phase of this workshop, and it's all dedicated to the question and answer to the member of the panel. So please feel free to raise your hand and ask questions, make comments, and we will have our three speakers discussing your questions.
So there is a first question in Discord. Maybe we can start. So it's an individual question, and then we can also have some more general question to the speaker. So this is a question from Tyranine. So for Dinesh, so you mentioned about how personality influenced the movement of pedestrians during the collision avoidance. So Tyran would like to ask, how do you classify if a pedestrian is aggressive or not?
So thank you. So, currently we look at the movements, and, we look into features like, if suppose in the crowded settings, right? And if you're a little bit stuck in a dense crowd with people around you, our assumption is that if you're aggressive, you kind of push your way out and move around it. And if you're a little bit less aggressive or, shy type, you will just slow down and wait for the crowd to clean up. So it's similar to behavior we see if you're walking in a crowded setting, or even when you're driving, people are aggressive like we are driving, and, on the highways, they change lanes, and sometimes in a crazy manner and pass the others. And people who are shy, are more relaxed, just will continue with a slow lane and slow down the traffic. So we have the same pattern. We're doing it because we are tracking your trajectory, and not only give you a position, but also give your velocity. And based on the information, we do it. And this is also based on some earlier work we had done. There was a paper we published about 9 years ago on using personality trait theory. And, we did a lot of data-driven models on how we classify the personality. So it's a lot of psychology ideas come from there. Thank you.
Thanks a lot, Dinesh. So
I may add a couple of words about what Dinesh has said. It's things like being aggressive. It's not really pure personality based. I think it's more of an emotional state kind of thing. You're not aggressive 100% of the time. Say you have a certain personality, and certain actions in the environment, like someone bumping into you, increase your aggressiveness. You can treat it like a reservoir with water that keeps filling in and then overspills. This is at least how we modeled it.
I totally agree. As I said, we were just, we say if you're just given a video and given, we don't know much about the emotional state, given the information of the movement, what's the best we can infer? So I agree with I totally agree with your comments of Anton, but just from the movements, the partial information, how much can you interpret? That's the kind of thing we're looking at right now.
Maybe Norman Butler, you would like to?
Yes. Hi. Hello, everyone. Great talks, and I'm delighted to see your work, especially Anton. But my question's for Nicholas. In really large-scale crowd simulations, there's probably a transition point between individual agent simulation and maybe painted or otherwise artist-created backgrounds. Can you address either how Golem handles this, or whether in fact you just punt and let the artists handle it?
So yeah, I'll probably say that it depends on density also. If you got like a really dense crowd, probably you don't want to have individual behaviors of your characters, and you're more looking into a fluid simulation rather than behavioral pass planning and that kind of stuff. So when it comes to this, all those packages that we are integrated in, they also provide fluid simulations, and we can just attach on ourselves. And regarding really large crowds, I think the biggest we made was 500,000 characters. And obviously when you address such a crowd, you have to be smart about it. You have to be smart about the way the geometry is going to be complex and probably provide some level of details. You have to be smart also about not putting really, high computational behaviors for every single character. When they are really far, you don't want to simulate probably fingers or hair or clothes. So when it comes to really large crowd, we got all those set of rules that we try to say to the customers, and when they can and when they have the time, they try to apply this. And when they can't, they just go brute force. And we're also here to be able to handle this properly. So, from day one, we knew that we're going to do hundreds of thousands of characters. So every line of code that we write, we try to, be smart about it.
Thanks.
There other question from the audience?
I may have one, maybe. So we are actively working around the topic of behavioral variety. I would like to, the three of you, how do you interpret this, like behavioral variety, motion variety, and how do you think it's relevant to address this? Because we all know it's super complicated. So let me
go first.
Yeah, Nicolas, just go.
So for us, it's probably one of the biggest issue we have, because this is how you sell the shot to the director, and the director just comes with a review, which is all the characters look the same, so provide diversity. And that's the comment you have, and you have to go into a technical plugin and figure what's the parameter for diversity. So we try to help with motion diversity just by having layers of animation, providing procedural noise that you can add on top of certain limbs, but it's still some acts, and we don't have anything like really natural. So that's for motion. And for behaviors, you provide different parameters for speed. We spoke about aggressivity. We've got also like a random parameter you can assign for aggressivity, which do exactly what Dinesh said, like pushing through the crowds when you're super aggressive, or when you're shy, you're just letting the people go through you. But for sure, if we had something more advanced, like a more comprehensive of what diversity means in terms of the shot you are, would be totally interesting. I haven't seen many papers on that topic, so for sure, I'm totally going to be looking into this if that was about to be published.
Yeah, I can say a few words. We have this behavioral diversity from the combination of personality and emotional state. So we have normally something like a random distribution of different personalities, and as agents act in the environment, their emotional state changes. So we, simply speaking, every emotion is a reservoir with water, and as actions happen, this reservoir fills. Someone bumps into you, your anger increases, and the rate at which it increases depends on your personality. And then at one stage, if it overspills, this is when you demonstrate your, say, aggressive reaction and start pushing through the crowd or start beating someone up. This is how we handle it.
So this is one thing I mentioned, most of the work in crowd simulation, we're looking into multi-agents, and some of the earliest model, we're using simple approximation, look at all the work on social forces, or even, or grid-based methods, or RVO. They were just using modeling each agent as a 2D circle or 2D ellipse. But recently, as we look at other humans, and you mentioned about behavior, emotion, aggression, I would say this whole thing about modeling the whole body language, full body motion, your face expressions, your arms, the way you move your body. So one thing in crowd simulation, we did a lot of trajectories and collision avoidance, but as we go into this area of more realistic conveyance of emotion, we have to figure out how to convey the full body motion. That's where I think I see a lot of open challenges. And just based on 2D circle and simple model, which was fine at that time because we were going for scalability. And as we heard, we can go so many agents that Nicholas mentioned, but there's more to humans than just the movement as 2D circles. So I see that as a big emerging challenging area in the next decade now.
Thanks. Jonathan, you?
Yeah. So thanks again for these nice presentations, visually very pleasing. But so this goes a bit to some examples Dinesh showed. So you had these two agents once, which was very like not very detailed, but where you said it had this different emotional states for this discussion regarding Corona and so on. And then you showed these meta-humans, which were like which are nicely affordable by now and very pleasing to look at. But then like probably the emotions were even better than for the other agent, but still they took me off because the hands, like all this delicacy and finger movement wasn't there. So what do you think? Is it actually worth going for best fidelity in graphics and then having the problem of uncanny valley perception mismatch, or what should we do there?
You asked a great question. You know, that my feeling, the whole notion of uncanny valley, right? You know, if you look at this whole human modeling, you know, and I'm sure we have people like Norm Badler who have spent like close to 40 years, you know, on this wonderful problem. You know, we have made a long progress, but there's always the uncanny valley, right? If you don't get it right and, you know, with a negative impression. It's interesting. I was just looking at your video on Zoom, you know, and I was just, now you're smiling, and thank you, wonderful smile, your face, your expression, you're moving your hands. I wish I could do this in my virtual avatars. We can't. It's like, you look happy to me. I'm so glad, right? Your expression, your face expression, your thing. So even on Zoom, I'm looking at you. I love this question and the expressions, but if I come to simulating my agent avatar, I can't come anywhere close to it. And you're right. And especially, you know, even the video that I showed, okay, the rendering has come up a long way, especially with all this new development and, you know, GAN-based rendering, neural rendering. The appearance part is getting really better. You know, that's a good thing. But appearance is only one part, right? Appearance is there, clothing is there. It's just how humans move their body, you know, the hand, the gesture, the face muscles, you know, faces are very complex. That convey, and that's where, you know, I think the challenge is. So, and if you don't do it right, even the video I showed you, you know, I was the first one to admit it took a lot of effort of 4 years of work. But if you look at my faces, your faces were kind of dull. They were nowhere expressive as emotive as people in this audience are doing. And if my faces are dull, that may just draw all your attention and have a negative impression, the so-called uncanny valley. So, you know, I think we should work on it, and I'm hoping someday we'll overcome the uncanny valley. I still believe in that. Eventually it'll happen. And all the recent developments, especially with all the machine learning methods, we're doing so much capture, we're getting so much data. So the data-driven methods, which have been a hot topic for the last 5-6 years with machine learning, you know, have definitely helped a lot. So in that regard, I'm optimistic that, you know, things will get better and we'll overcome the uncanny valley. I hope so.
I'll just add, I think we are very close to breaching the uncanny valley, but even if we don't, right, even if I'm much more cartoonish than I should be, I'm still okay. It still looks fun on Zoom. Even if the character just does random gestures and just lip syncs to my voice, it's still good. And after a while, you forget that that's a virtual character and it's fun to interact with.
But because it's cartoonish, right? If that was a meta-human, it would look weird. Maybe.
Not necessarily.
Okay.
Not necessarily. I mean, we already have technology to capture finger movements and facial expressions. It's all there.
This leads to a really important question: is, does your avatar look better because we know what you look like, or do we accept you because we don't, in a general way?
That's an excellent point, Norm, you know, as because I know you, so I could even, you know, okay, I can't simulate realistic Norm or realistic face or Nicola or you know, or even Julian. I can take Julian's voice and take a cartesian avatar because I know Julian for 12 years or Anne, you know, so I'm accepting that. But if I don't know you, right? So this is where a lot of evaluation has to be done. How far we can, right now, all social VR, all this metaverse is based on cartoonish human. What are the limits of cartoonish humans? You know, where can we, how far we can go? I don't think we have a good answer right now. I'm just looking at my Zoom screen, you know, I look at I'm on the left, I see, you know, Annie, I see Julian, I see Norm, Jonathan, Anton, all the 6 people you speak. And I'm looking at everybody's face video, and that everybody's face is so lively. And if I replace all 6 of you with cartoonish, you know, I don't think it'll be the same. It's better than nothing, but it's not the same. That's what I feel.
I think it's all because we had a good time this session.
Yep. Thank you, Tom. I feel good. Good talk. Yes.
Other questions from the audience? Don't be shy.
Do you have time for one more for me?
Definitely, yes.
Okay, so this is about virtual reality. So there are clearly scalability issues when you take virtual humans into virtual reality. But what are the other issues you've encountered in doing things in real time? All panelists.
I mean, obvious issues like cyber sickness and materials not showing correctly. We have a lot of it in, especially with Oculus, when we do architecture visualization. Many materials are way off and start flickering and things like that. Things that come to mind.
So now one thing, that's again one place, you know, recently this you know, we used to do real-time graphics, GPUs, real-time simulation. The recent trend, there are a lot of papers on doing machine learning methods. Of course, machine learning has its own problem because there's no guarantees you can give. But at least even for some of the things like I've seen, like human motion or even growth, you know, there are all these new papers coming up on neural processing, and all machines have neural hardware. So I think the advancement of machine learning techniques and the machine learning hardware, even coming on your smartphones, definitely help in that direction, that you can do more things in real time than before. So in that regard, I think that's also a positive step. But again, let me again say, you know, machine learning is also overhyped. And one challenge of machine learning is you cannot give guarantees. If your network did a good job of learning and data, yes. So in the best case situation, you can real time, but in the worst case situation, there are no guarantees on the result.
I can also share my experience here. So what's taking probably the most time for us is everything which is like simulation based, you know, close hair muscles. Every time you want to bring a character really close and you want it to be really believable, you had to bring simulation into the party. And obviously when you do this on dozens or hundreds of characters, you kind of really slow up what you can get, and can be really disturbing. And as Dinesh mentioned, you know, deep learning, machine learning comes to the rescue here, because as it's stimulation based, we can generate plenty of data offline. We can learn from that data with deep learning models and reapply this real time. So this is also kind of stuff that we are doing now, like try to understand what is a close simulation, what is a muscle simulation, what is a hair simulation for crowds, and try to reapply it in a short context to have real time or at least better performances.
Thank you.
If I may add, I think there is also something specific to VR compared to screen show of simulated virtual humans, is that you are sort of co-located with a human, so you are in a one-to-one scale interaction, and you are observing it, and very often it looks like he's not aware you are here, right? So that comes with animation, because yeah, awareness, or if you, I often take this example with students, like if you clap your hands, he will do nothing, right? So he's not even reacting to the most basic kind of stimuli. So yeah, I think this should be the next one of the next evolution of virtual humans for virtual reality, which is very specific. That was just a comment. So I think we have reached the end of this workshop. We are 2 minutes beyond 11 here in France. I'm not sure where in your place, what time is it, but anyway, we are over time. So let me conclude this. I don't know how actually, because we were discussing online who should conclude this. So I don't know what to say to conclude, but we were very happy to have you here. Indeed, there was a bunch of really great talks, and I hope you enjoyed it. I think something we agreed on saying is that we're running this workshop for how many years? We have run for 8 years, 6 years, I don't remember.
7.
7, so it was in between. There is really, we are always wondering whether we should do the next one. I think we need some fresh blood here. We need some inputs from you, not to always come with the same kind of things. So whoever has any idea about what should be discussed here in such workshop, and if we have nice ideas from you, the audience, anyone, we would be happy to take this maybe to consider and make a decision here whether we submit again this workshop or not. So yeah, and with that, I would like to thank you all for being there, presenters and attendees. And that will be all for me. Maybe see you next year. Anyway, see you physically somewhere soon, hopefully. And yeah, so I was saying this, VRE is very unlucky. That was one of the first event moved to virtual and probably one of the last one, hopefully. And yeah, so we will next time maybe have a beer after such an event and discuss more. Thank you.
Thank you, everybody.
Thank you.
Thank you for organizing.
Thank you, everybody.
Thank you to all of you for organizing, and thank you for the Zoom support. Appreciate it.
Thank you. Bye.